This conference will now be recorded. This conference will now be recorded.
Yes, good morning to everyone. This is Professor Gautam D. Makwana from the GTU, British School of Engineering and Technology, Ahmedabad. So this is the day number 4 for the ISEA project to sponsor 5-day online faculty development program on the Internet of Things with the machine learning and artificial intelligence. This FDP is organized by the GTU, British School of Engineering and Technology, Ahmedabad, in association with the Center of Continuing Education, National Institute of Technology, Warangal. So in the last 3 days, we have the different kind of the expert for the different kind of the outcome and their finding on the IoT, machine learning, and artificial intelligence. As a part of this FDP, today we have the expert, Professor D. Ramesh from the IIT Dhanbad, and I welcome behalf of the GTU, GSED, and the CCE NIT Warangal. So good morning to Professor D. Ramesh, sir. So as a part of the as a part of the thank you, sir. As a part of the introduction point of view, Professor D. Ramesh is the assistant professor in the Department of Computer Science and Engineering at the IIT Dhanbad since 2011. He received his doctorate degree from the IIT Dhanbad in Computer Science and Engineering. His area of research are machine learning, deep learning, blockchain, brain-computer interaction, cloud computing, data mining, and big data analytics. It is happy to inform you that Professor D. Ramesh has been completed 2 research projects from the government body, and the 2 projects are ongoing in his credit in the area of the machine learning and the big data. He has filed 2 patents in his credit, and he has published the more than 103 research paper in the peer-reviewed journal, and currently he is guiding 8 PhD scholars. So in this case, we are very happy to have the expert like Dr. D. Ramesh sir with us to giving the his finding on the based on the machine learning and the IoT uh, uh, as per his area of the interest. Our topic of the today's session is the machine learning based paradigm in the agriculture application. So this is our introduction about the Dr. D. Ramesh, and I welcome Dr. D. Ramesh, and I hand over the session to Dr. D. Ramesh, sir. So thank you very much, sir. Over to Dr. D. Ramesh.
Yeah. Thank you, Professor Gautam. Very good morning, my dear faculty fraternity. Thanks for joining this session. Yeah, I let you know. I could see means maximum number of participation, and I do not know that from which places the people are participating. I think from overall India, I believe, right?
Yes, sir. Yes, sir. All over the
Yeah.
across the India.
Yeah. Great to see. Really great. Fine. Okay, we'll go through some interesting topics today. Before going to that, let me configure the strategy of ML with respect to IoT. Okay. Yeah. So probably this that I'll introduce 2 findings throughout my lecture. If time permits, and I'll try to finish the same as early as possible with respect to the time duration. Fine, great. Feeling so happy to share my findings with you up to some extent. Yes, I cannot say that these findings have been completely memorized and completely triggered towards some related applications. But more than 80%, I could say that yes, these strategies have been propagated and deployed for various application usages. Yeah. The first one that the first paradigm named cross search algorithmic strategy. It comes under heuristic technique or combination of meta also to some extent. It's a kind of ML paradigm. Let's see that how this paradigm has been evaluated and validated towards an application. Yeah, one important point I would like to convey from my side, mostly in India, means like academicians and researchers like us, what we do, we try to exemplify the possibilities of algorithmic strategies in our own way. In the sense, just taking a kind of data set and performing the evaluation with respect to that and memorizing the related results, and we can simply by assuming something, we can simply say that yes, this kind of concept can be utilized for something. This is a kind of theoretical finding, I believe, right? The actual meaning comes when we do with the actual meaning. Yeah, actual meaning can be achieved when we do with the validation with respect to, at least with respect to a scenario which is applicable and completely fit, which will fit under a particular application, so that that application will be utilized for the society sake. Okay, yeah. Let me correlate the things that why, because correlate things with machine learning paradigms. Why? Because I'm not going to have the paradigms of, or I'm not going to discuss about the IoT type of issues here, right? In my opinion, I have two types of findings in my mind, especially related to IoT. And today, this term is knocking us every day, that is evening and morning, that IoT. And I don't have much experience with IoT, but I'm experiencing the services from the IoT. Then how the IoT case has been validated. Then apart from device, I'm speaking. Apart from device, I'm speaking. So if I speak apart from device, means beyond the device, then what the scenario will come? Ultimately, the distributed computing. Ultimately, the distributed computing scenario. If the distributed computing scenario is can be managed in a proper way, then definitely that your device will be ready to use. Why? Because device is the combination of something, and whereas your distributed computing is the combination of something. We are correlating two different platforms here, my dear friends. That when people have an illusion like that arranging the IoT device with respect to the individual nodes in the distributed computing scenario, the computing can be done. No, this is completely wrong. Completely wrong. So that's why we are lacking, and we are inviting the abroad-based companies to establish their business in India. Then this revolution has started from 2012 onwards, I believe, and even Indian companies started exploring the things beyond the design. What? Design with respect to computing scenario, not the device related issues. Why? Because see, if I would like to purchase a cam, or if I'd like to purchase a mobile, that is available in any form in the market. But how to make use of that? Then how the integration can be provided to that particular device is an important issue. See, your device may be composed with different functional units, but ultimately the network issue comes. If the network issue is not sufficient, to perform, then you can throw your device into the box. What box? Dustbin box, like. Yeah, this is the way. So if we start from the scratch, there are three things need to be considered. The first thing is that what kind of constraint we are going to analyze. Yes, if I choose that a kind of algorithmic constraint or paradigm that we are going to analyze, yes, you can choose that. And the second one is that how the particular constraint can be validated with respect to the modality of computing. Yes, this we can do. Then after framing the modality with respect to computing, then there is a question, then there is a part of IoT device comes. So finally, what we are doing, we are making means we are creating a road flow, a road snap. If the road snap is ready, then definitely the platform can be utilized. Yeah, so this thing you have to know. Why? Because people are having a kind of illusion that combination of IoT and related paradigms of network and something paradigms can be integrated together. No, this is wrong, completely wrong. Why? Because the second part comes under distributed computing or something a kind of computing environment. If the computing environment or platform is not ready or a road snap is not ready for us, then what is the use of device? Yes, if you take the example of IoT device like that is managing the activities like switching on the lights and fans and everything, then what kind of paradigm, then what kind of approach has been deployed, means was deployed in that? A kind of paradigm it is. Then it is not an easier task to validate and deploy the application oriented paradigm into the device. It is not that much easy. That you have to, means we have to analyze it properly in terms of its working strategy, right? And any debugs, any bugs are occurring, or any kind of debugging aspect is required or not, right? And after testing in all the ways, in a proper manner, then only the concept can be deployed in the device. Now, the second stage of testing comes with respect to device, whether the proposed or the deployed paradigm, the kind of paradigm, any strategy is working sufficiently with that device or not. Yes, we have to check. I can give you one best example, that is Alexa Echo, Amazon Echo at our home. Right, simple thing. If you don't have internet connection, then you could not able to retrieve anything, except if you have the local storage in your mobile and that is connected through what's that? Connected through Bluetooth. Yeah. So what's the use? You can listen songs and you can play videos with audio only. Then if the interconnection network concept is failed, then what is the use of that particular device? Nothing. So what I mean to say here is that if you consider the upper layer as a computing, then it must be analyzed in a proper manner. So my discussion will be in this mode, my dear friends. What I do, I'll try to validate two types of ML paradigms, right, with towards the application. So now this is up to the industry industry opinion. If the industry wants to take it granted, yes, it can, and the same can be deployed into a particular device, which will be helpful to the farmers up to some extent. Then what kind of device it could be? It could be a kind of sensor, and the sensor can be deployed in a particular device, and the same can be arranged in paddy fields or somewhere. Paddy fields are somewhere. Nowadays, some different new applications have been configured.
Hello, sir. Sorry.
Provide...
Hello, sir.
Yes,
Hello.
please tell me.
So,
yeah,
only first slide is coming on the display, sir.
Yes, I'm coming. Okay. Yeah, I'm coming. Yeah. So this is the way. So how? So application must be used, right, for further usage, and that must be useful for the society. Okay, yeah. Let's see that how the IoT and ML can be connected each other, interconnected each other. Yeah. So if you see the paradigm of IoT, right? The paradigm of IoT is completely dependent on what? It is completely dependent the scenario of machinery. In which form, IoT sensors are added to the machinery that looks at discrete variables such as noise, heat, and temperature, blah blah blah. See, just underline this point that IoT sensors are added to the machinery, my dear friends, machinery only. So it is a peripheral unit, physical unit. We can't have anything except some kind of circuitry design. That's it. But that circuitry design is designed by one of the layer. So I'll let you know what is the layer it is, right? So what we can treat, finally the machinery that looks at discrete variables such as noise, heat, and temperature, other kind of parameters, whatever the parameter you consider, it comes and considered as data. So this data is then uploaded to one of the repository. Whether the repository could be the local centralized database or distributed database or a cloud centralized database or a cloud distributed database or something, whatever it is. So this data is then uploaded to a kind of repository. Now the actual work starts from there. Now a kind of backend in terms of data is available for us. Then how we are going to retrieve through the device? Like I have just explained the example of Echo, Amazon Echo. If I say that, if I speak to Amazon Echo, right, Alexa, please play Vishnu Sahasranama. Example. How it is playing, my dear friends? Definitely there must be an access. So just eliminate your illusion. Eliminate your illusion, or just remove the illusion from your mind that nothing is there in IoT device. But we are performing something beyond that. What? In terms of only interconnection. If interconnection is not there, then there is no use of IoT device. Zero. Okay, so people are mesmerizing the community by speaking that if we interconnect these two, then something can be done. No, it is wrong. That you have to make sure the environment of computing quite feasible, quite available. Okay, so in this way, the IoT can be interconnected with the network. Now, what kind of parameters the network can have? Simple, except communication. I was speaking, except protocols that I'm making means I'm giving the possibility to the Alexa to sort the related songs based on Vishnu Sahasranama. If I speak that Vishnu Sahasranama by M.S. Subbalakshmi, then lot many tracks may come in the memory of Alexa, but it is analyzing. So some kind of paradigm is working behind. Yes, so that part is integrated in terms of machine learning validation. So that ML paradigm is validated and deployed in the computing scenario, in the form of computing scenario, and that computing scenario is attached with IoT device in terms of network. Yes? Any objection from your end? This is the actual thing happens with IoT and network type. So what the network follows? Network follows except some protocol, except the protocol mechanisms, network follow ML paradigms, machine learning. Simple. That I'm not going to correlate the machine learning and artificial intelligence up to some extent. Even the Alexa may be fed, Alexa may be given the possibility of AI sensing. AI sensing, that I do not know that how the sensing can be provided in terms of ML validations. I'm sorry, I did not perform any kind of experiment till today. Okay, yeah. Now ML comes into the picture after choosing the added machinery in terms of discrete variables, varied variables. Now the part of ML comes into the picture. right? And the where the machine learning model sits, the machine learning model sits on the top. Okay, the machine learning model sits on, just wait please. Yeah, sits on the cloud platform feeding on incoming data. Just sits on the kind of platform, not cloud computing platform completely. Then it's up to you. If you could have established a different platform, it would be easy for the device to interconnect or do something. Yeah. So finally, the ML comes into the picture, and the learning model sits on the cloud platform for feeding on incoming data. So that's why. And the ML model feeds the information into data used for training and for verification. So each and every time the same thing will happen. Why? Because if I change the modality of playing Vishnu Sahasranama immediately, then I'm instructing my Alexa to play Vishnu Sahasranama with other voice, with other male voice, or other combination of male and female voice, or other female voice individually. If I instruct like this, then again the training and testing can be done individually. So this possibility is also deployed in the form of algorithmic approach, my dear friends. Means what I mean to say is that your algorithmic approach is working like anything. It's a strong weapon, I would rather say. Yeah. Finally, how the model looks like, the model looks like in hundreds of thousands of records of anomalies, correlations, and projections to come up with hypothesis background. Yes, once hypothesis has been created, it needs to be tested and validated. Without these two, the testing and validation, you can't move forward, or you can't move further. It will be a zero innovation. It will be a zero innovation. I can give you one best example. See, the platform for running, the ground is ready. Ground is ready. Even the participants are ready. But no competition happened at that moment. What is the use? These two individual entities, such as that is track, means like your IoT device, and the participants, like your competing scenario, these two are ready, but no competition happened, no integration happened. What is the use of that? Nothing. Yes, in this way, we can mesmerize with the ML paradigms or something, algorithmic type of paradigms to make the IoT industry available. Okay, final one. Once a model has been validated, excellent, it's published as an executable endpoint. Okay, executable endpoint. Next, the live streaming of data can be passed through the trained model and make the same in terms of machinery based upon what it already knows and happened, what we are looking for. So this is the connection between IoT and ML, my dear friends. So this how the scenario comes, especially based on the validation of machine learning strategy. You can assume in your own way. Machine learning strategy is an algorithmic approach. Apart from generalized algorithm, I'm speaking. Not like if I process a generalized algorithm with respect to individual machine, that individual machine can perform something. But ML paradigm is not like that. That a kind of approach in terms of machine learning is integrated with other paradigm, device or other functional unit. I would rather say that IoT device is a kind of functional unit. That's it. Right? So what we require finally, validation of approaches. Whatever the approach you suggest, it should be validated in a proper way. Then only the connection with IoT can be established, and we can enjoy the environment of IoT. This is the way. Yeah. So moving forward, let me introduce a concept that in what way kind of ML paradigm has been validated. It's been validated. Then I'll show you two types of findings here. Right. The first finding is with a kind of heuristic algorithm or meta heuristic approach named cross search algorithm. It is a kind of optimization strategy. Okay, I'll let you know time by time. Don't worry. the outline of this presentation, starting from this point, is that I'm introducing something about and a kind of paradigm I'm introducing. Then let us mesmerize the environment by taking the case study, by evaluating the case study environment. For this, we have chosen the Karnataka state with available data deployed through sensors, and what is the model description finally, then how the result can be outlooked, and if any out-of-box situation is possible or not, and we'll see other type of conclusions in the form of your suggestions. Let's see that. Yeah. So introduction in the form of motivation is that the prime goal is the access of food to all human beings on the planet. Right. You know what happens then, as per the strategy of FAO, that I have given only 30 years for next 30 years. Then if I consider next 50 years, the situation will become horrible, my dear friends. Will differently means will become horrible and horrible. And the due to the global population, and this population is increasing to 9.7 billion persons for next 30 years. Then if I calculate for 50 years, I'll show you the strategy of the 50 years in upcoming finding. Okay. Yeah. The problem of increasing food demand can be achieved by delivering advanced scientific solution to farmers. Why? Because farmer is the mainstream in producing the food for our country. Not only our country, maximum 90 for 90% nations. Right? So what we do, then we supposed to provide an easy solution which can be useful for the farmers to take the decisions in a rapid way, so that they can optimize their cropping strategies time by time. Why? Because the today's environment is not fixed. Environment condition we can't assume. If I say in a fixed manner, yes, in September and August only the rain happens. No, I can't say like this. And due to the global warming, the situation of the environment is changing day by day and time by time. Then how can we analyze the how can we analyze various strategies related to environment or depending upon the environment and nature, right? So a perfect planning is required in terms of what? Being a research community or technical community who must and should contribute something to the society, especially as a mainstream such as agriculture, healthcare, and others. Except technology, I'm speaking. Okay, right. Even if we see the rustic type of mechanisms followed by farmers. So yes, rustic type of means yes, but how? But how the farmer is analyzing the things? Why? Because farmer is not literate, means having not having literacy up to maximum extent. If you see the population, 40% population is illiterate in such kind of community. Then we should provide something in terms of a sensible approach, so that that sensible approach can be used at the end of farmer. Now let us leave that to the farmer, and in what way the farmer can provide the facilities to the generation. Simple one. So here, yes, as I told you that I'm excluding this term, my dear friends. Artificial intelligence. Adverse effects are reduced mostly by using AI-based applications. I do not have any idea about this one. If the proper approach is validated and tested for something, now this is up to the industry, then the industry will take care of that. And industry will design the required amount of peripherals which are useful for farmers and other type of community, especially. So I'm not going to knock on AI-based communication or something. So I'll speak about I'll speak about the paradigms of ML which can be embedded and deployed with the AI-based technology. So this is beyond This is beyond our assumption, I believe. This is beyond our assumption, right? Then how the assumption can be triggered in the form of application? So assumption can be triggered in the form of application in two ways. That is, the first one is that making the theory solid, means in a meaningful way. So if I say something that yes, I can design a sonic flight which can reach the US within 2 to 3 hours. So this is my assumption only. But how the assumption can be moderated, right? So for this, you have something that is some kind of connection beyond, or some kind of thinking beyond the assumption, right? So that is the third type of layer approach. First type of layer approach is that gathering the requirements, and that requirements are going to be fulfilled by validating some kind of approaches which are known to us and which are feasible from our side, like ML. Why? Because we can beg it. We can see that yes, if I write an algorithm, then I can see the exact outcome and outcome based on the input provided. Why? Because I know the strategy. If something goes beyond or something goes wrong with that, yes, I can put my hands and I can rectify the problem. But AI is not like that, my dear friends. If the control goes beyond to some other entity, then we do not know that in what way the application behaves. Application behaves. Example, let me give one best example. Just few days back, I heard a news that one guy in UK wants to reach the destination. Then he arranged a map according to the route he known, but he went to the sea, and still that path is showing towards into the sea only. So what kind of strategy it is? I mean, it has gone beyond the hands, or it has gone beyond the application we designed. So that is the third assumption called AI. So if that AI approach is not verified in a controlled manner, in a meaningful manner, then that application will bring some kind of loss to the society. That's what. So that's that kind of information I know about AI paradigm, but I'm not going to speak about AI. Let me introduce the concept of ML, where the possibility of ML validating ML strategy can be deployed. Must be deployed, not can be, must be deployed. Why? Because we are the persons validating in terms of all possibilities, and we can also know that what kind of error is going to happen in the next moment. Yes, say I'm feeding the data for last 20 years for environmental conditions, my dear friends. Okay, then based on that one, I can have a calculation up to say upcoming 20 years by varying the environmental conditions. Like this is September going on, and here some kind of humidity is happening in my location, geographic location, but in your location some kind of rain is happening. So let us feed such kind of variated attributes and we can get something. If the limit goes beyond the variated attributes, then definitely we may not get the exact result if we analyze the ML paradigm in a proper manner. Yes, that is in our hands. But if I speak, or if we see AI, that no one can say, even the robot designed from a particular kind of entity or by yes, human entity, even cannot assume that if something goes wrong with a particular robot, then how the behavior would be. Yes, so ultimately that we should not compromise in validating any paradigm. Like if you take the or consider the example such as the technical issues or devices or protocols or whatever designed by the abroad scientists. See, they don't compromise, even they don't rely. After producing the result, what they do, they'll keep on performing testing. Then if something goes beyond wrong, then definitely that must be configured within the time span. So that's why the people are enjoying and we are depending upon them, my dear friends. Yes, just take the example that the guy or the farmer who is having 100 acres of land and who is establishing the business of what's that, say ragi and something, that the individual farmer can manage the activities of that 100 acres field in a single hand manner. But if you take the example of India, it is not reaching. Why? So again, some policy recommendation type of issues also, irrigation type of issues also, or even the farmer is depending upon the sensor purchased from the market and he deployed in his fields, but up to some extent that particular sensor stopped working. Then what is this? Then immediate assistance must be required. So that we are lacking up to some extent. So let's see that. So these are the genuine policies need to be considered in and around while designing the application. Okay, yeah. So while moving to the actual strategy, that a finding I'm going to establish here, that is a type of meta-heuristic algorithmic approach named Crow search algorithm. Let me tell you the story of this one by giving the background of others too. Except conventional paradigms like excellent, like GA, genetic algorithm, or combination of genetic algorithms, particle sum optimization, and again, even one of my professor in my department also validated a concept called CRO, chemical reaction optimization. Lot many things. These are are available in the literature, and people started working and they are exploring their importance with new findings. They are doing excellent. When I started exploring the things from a specified algorithm such as grasshopper algorithm, that point onwards, I started thinking in a different manner. Then why don't we do with upcoming new meta-heuristic approaches? Why? Because the newly established and arrived meta-heuristic approaches provide the feasibility in performing dominated and non-dominated solutions in a given search space, my dear friends. In a search space means you have the possibility of optimizing anything from your end. Say, let me consider a type of algorithm, a kind of algorithm X, that the feasibility of algorithm is limited up to 50 iterations. Yes, up to 50th iteration. Thus, if the 50th iteration is performed, then definitely it will produce a good result. But the possibility of the particular algorithm cannot be extended beyond. If yes, something can be extended beyond, it may produce good results or bad results. But the case of meta-heuristic algorithm is not like that. Not like that. There is a possibility and feasibility given to the community that based on the requirement, you can fix the working of that particular structure or working structure of the particular algorithm. Then if you want to further extend the same, yes, you can combine another approach with the existing one. So the combination of, say example, if I say the combination of genetic algorithm and particle sum optimization, it's your wish, and colony optimization, lot many things. So we can have combination of all, but the meta-heuristic approach possibility, approach possibility is really somewhat meaningful. That we cannot fix with a kind of moderated type of communication, moderated type of experiment analysis. We can further extend. That extension may be, in terms of producing good results or bad results. But we must have a kind of experience so that we can concurrently and constantly say that Yes, this is the possibility of this algorithm, and the environment of the application environment can be tested for best usage of anything. Right, this is the way. Yeah, so for this reason, I started exploring the meta-iris type of algorithms from by considering grasshopper, spider monkey optimization. Then I also worked on hybrid spider monkey, exponential spider monkey, and later on came to this approach. And even I started linking the possibilities of newly established meta-heuristic algorithms with the popular algorithms like GA and PSO. My dear friends, the services or the mannerism or mechanism of GA is really excellent. That lot many applications have been built. Great. So I'll knock on this one. Yeah. So in this finding that I'm establishing a kind of paradigm named CSA, which is established by the community Askar Jeddah. I'm going to make use of this algorithm for a kind of application, especially agriculture. Let's see that. The approach started by considering the nature of the crow. The crows have been to observe other birds, and when the owner leaves the hiding place, they steal the food. This is the possibility captured from the crows group. Right? Based on the genius facts, exact facts, the fundamental features of crow sets algorithm are listed as follows. These are the four features. First one, they remain in the class of a collection. Excellent. This is very easy to frame the say only crows are gathering the food. First type. Some crows are quarreling, and some crows are hiding. Some crows are gathering and quarreling. So this kind of class connections and collections we can make easily. Yeah. And the second feature is that the crow means crows remember their hiding food place. They follow, sorry, typo mistake here. They follow another crow for stealing the food. Crows hide their catches to protect from being pilfered by others. Excellent. Because of these different fundamental features, this finding has been considered. Okay, let's see that how the same can be propagated towards an application. Yeah. As I told you that in order to analyze any kind of algorithm or any kind of optimization strategy, we have to have set space, means possibilities of testing in all the way, right? So the set space has been considered in a form of vector. The vector is specifying the set space, means a set space if you consider like a room space and something, then it is analyzed by accommodating different aspects of attributes. Okay. There are two types of connections have been established. The first one is that CR, go, I with IT, two types of principles with some limitations. So I is from 1 to capital N and IT is from 1 to ITM, where here capital N represents the number of crows. Great. And ITM is defined as the highest estimate of repetition. Highest estimate of repetitions. In order to predict the food from other crow, that one crow is going up to the maximum distance and again suddenly coming down and again changing the flow of its direction. See how the optimization strategies have been considered here. All possibilities in a set space, right? Where the second one is having some kind of limitation in terms of its memory. Why? Because we have to fix the principles in terms of different computational aspects, means possibilities, randomized possibilities. So the second equation speaks about what it speaks, yeah, all number of crows having, given the possibilities of the number and the highest estimate repetition, this kind of equation is established. What it says, the memory is the memorized location of each crow I at iteration IT and is the food hiding spots. So one crow can have various food hiding spots. So these are the all constraints going to be molded, going to be integrated at one place in the form of collection, one collection. If I speak about only gathering foods, yes, it comes under one class. If I speak about the quarreling, it comes under one class. Or if the combination of crows are flowing towards a kind of particular direction to gather the food, it also comes under like this. So these are all types of possibilities have been considered here. Okay, so let's see that how the same can be analyzed for further usage. Yeah. So what it says here, simply, that probably it may not be visible to you, my dear friends, but just see. Here I had considered the crows participating in the form set space line with their origins like, okay, yeah. What it established, it established two events. The first event is that in event A, at the same iteration, say crow I is moving to see the hiding position of the crow J, that is memory of J in a particular iteration. Okay, crow J. There are two events can happen with this in this kind of particular scenario. So if we consider the possibility of examining the same with say spider monkey algorithm, right? The only difference here is that there the group of monkeys will be considered, but here the combination of single and the combination of crows may be considered. See, the possibility is extended for up to a competition level. Up to a computational level. If you consider, if you want to mesmerize the environment with say spider monkey kind of thing, say monkeys can't move individually; they move in a group with some limited number, with a leader like. But here crow doesn't require. So because of that, and as compared to monkey, the crow is intelligent bird, really intelligent bird. Right, because of that reason, all the possibilities have been considered in terms of various attribute formations. Okay, so this, when the crow I is moving to see the hiding position of the crow Z, it invites two events. So event one is, sorry, crow I find the hiding place of crow Z because it doesn't know it followed by crow I. Sorry, a typo mistake here. Yeah, so this is established in terms of CRI, crow I, then increasing its iteration means checking the possibility in other one. The first one is that basically crow one is moving towards in direction to find the food, but meanwhile it found that yes, other crow started hiding the food somewhere. It cannot recognize the location. It cannot recognize the exact location, but in and around to the particular location, in and around to the particular location, the crow can set. So what immediately the crow I considers, it simply diverse. It simply take a diversion, means from one iteration to another iteration. So whenever it moves to the another iteration, what happens? Then what happens? It specifically, it means it moves into the location towards, means in and around, location towards the food hidden by Z. Right? Then, after reaching to the nearest location of the food, again the crow may started walking. So another type of iteration. See, for a single instance, in a single instance of a particular single crow, means type of conditions, these many number of possibilities have been considered. Means what I mean to say is that, see how one direction is giving the optimization possibilities in various forms. So that's what a kind of strategy has been established in the form of this algorithm. Yeah. Finally, if it finds then fi of I flow, that the flow direction of the particular flow manages the food hiding place are finding are going to see this place, then definitely it will decrease the flight length, say upper to lower, lower to upper, or with moderate speed. So the same has been considered in terms of an integer range from 0 to 1, starting from 0 to 1. I'll let you know that in what way this interval can be maximized and minimized, and can be moderated based on the flow of direction occurred are happening with a particular individual crow or group of crows. Okay. Event 2, if you consider, crow J moves to a different place to fool the crow I. See, each and every time that crow I is stealing the food of crow J, that sometimes, after some time, the crow J found that yes, the crow I is stealing my food. Then let that crow I will be fooled. How? Then what that J will do? The J will choose different places to fool the crow I. It will pretend like yes, at this place that I'll be keeping the food. Let me pretend, and after that immediately I'll flow to another location like this. So it may change the possibility. So what's happening while crow I is coming to off the food? What's happening? The execution time or something that is increasing, the iteration level is increasing with crow I. So this is the possibility. So what are the possibilities up to some extent? Till the energy loss of the particular crow I, it can set the food hidden by crow J. Maximum level. So ultimately what comes, my dear friend? Energy level. So this kind of energy attribute, yes, energy attribute can be molded or deployed in the sensor. If the energy of the sensor goes down, what happens? You know, the computation possibility will be doomed. It will become black to that. So ultimately, it cannot produce the required outcome. See, a simple mechanism we have learned from a kind of bird like crow, and making the computation for real applications. Excellent it is. See, only 2 events happening with a kind of meta-heuristic approach. This is designed by human only. See how the human mind is working like. But this is with all possibilities, my dear friends. Possible possibilities, not assumption, not going beyond. Even I cannot say yes, if a flight is given to me, I can reach to US within 2 hours. No. So feasibility come possibilities analyzed in a proper manner with the help of this kind of meta-heuristic algo. Okay, so let's see other happenings. Yeah. So finally, 2 events are calculated as follows. These 2 are merged. That is the random position of a particular crow which is searching for food, or going to off the food hidden by another crow. So these 2 are molded in one particular location, and this is calculated in the form of mathematical possibility, like a probability condition, that is awareness probability condition. So another mathematical term has been established. So as you know, each and every algorithm must be validated with its proper mathematical term. Then only it comes to the it comes into the reality. Otherwise, it will still remain with theory only. Theory we don't believe, my dear friends. Theory we don't believe. Yes, we can frame the modalities in terms of, but until and unless we experience with that particular theory modality in terms of technical validation, then only it comes into a form. That's right. So a kind of awareness probability modality has been established, which controls the diversification and intensification of the particular bird or object. And finally, this meta-heuristic algorithm provides the right balance to the modalities of a crow or combination of crows. So this is in this way the concept has been framed. Yeah. So what we analyze, that we try to analyze the same by taking a case study of Karnataka state. Yes, as usual, and for every state, the agriculture is the main occupation of the rural people. For Telangana, AP, Tamil Nadu, whatever, except some hillsided states in our India. Okay, even so, 75% of the rain received from southwest monsoon, especially I'm speaking about Karnataka here. So, agricultural land is covered by 64.60 percentile of the total geographic area of Karnataka. Right, that we have differentiated the things based on the deployed sensors here. The type of soil is red soil. That area in lakhs of hectares is 71.08. That is 37%. Black soil is 28%. Alavo soil, right, is 16%. Lateritic soil, forest soil, and coastal soils like this. Rock lands, water bodies, and urban areas are 3%. So finally, 190.50 lakhs of hectares type of soils have been occupied. Yeah, and what kind of crop can be taken into consideration based on the condition of the soil with respect to season-wise normal rainfall. Yeah, so this one, this is the condition. This is the condition of the soil taken right till 2008 based on the availability of available data from the sensor. So from January to March, summer is 11.10 rainfall millimeter, April to May pre-monsoon, and June to September southwest, and October to December northwest monsoon. And this is the actual total. So these are the preliminary constraints have been considered to perform the strategy. Yeah, the case study further continues that up to some extent the cultivated area under the all has been considered by taking different types of crops here. That is rice, maize, jowar, ragi, groundnut, blah blah blah, all types of sunflower, minor castor, all everything, right? So this is a kind of study scene that I would like to show you. But let's see that. Yeah. The data is taken from various central and state government departments, which are collected to the deployed sensors, right, by various agencies. Right, you know, India, what happens? Except I could see, except the Agriculture University in Hyderabad and Ranchi and somewhere in Ahmedabad, Uttar Pradesh, something, then they have established their own sensor mechanism supported by China and Japan. And some sensors were deployed by ISRO itself. So to know the environmental conditions only. But individually, the people made some kind of programming to know the condition of the soil penetrated with. Right. So different crop water requirements have been considered here. For the particular by considering the type of soil and the environmental conditions, rice required 648 millimeter of water, cotton 941 millimeter, sorghum, millet, right, sugarcane, wheat, barley, mustard, gram, like this. So this is the available data from the Government of India website that we have taken. So how the proposed mechanism is deployed and validated in terms of that. Yeah, this may not be visible to you up to some extent, but let me read the contents up to some extent. Sorry, I could not able to accommodate all the parts in a major manner, level. Right. So as usual, the start verifying the same. So what is the initialization here? The initialization is that to check the possibility of the crop and yield with respect to the factors based on available water resources and area ready for cultivating. Okay, so this is the first step. Then evaluate the fitness function for each crow. Then the crow concept has been modeled by taking various types of flow directions of water and other. Say irrigation system has been defined and a particular dam is going to support the same. And say there are 16 small canals have been arranged to transfer the water from the dam to various locations. Say example. So what happened here, that if you transfer the flow of the water with some limited count, then definitely that all the fields must be undertaken. But something is happening here, my dear friends. Say one of the canal got damaged. Means the water has to flow, supposed to flow in a particular direction, has been diverted. As I told you, the cross-hatch mechanism, like going towards one direction, but changes the modality of the direction to know something. Like, so number of operations are. So what we do? So this we can monitor by fixing the same in a kind of say helicopter type of drone type of equipment, and we can moderate the mechanism of the algorithm. Best example, one example I can show you, but I cannot make you to understand fully here. Right, this is the one. And what we do, we try to evaluate the best maximum fitness functionality of each and every individual object or direction flow towards, right? And finally, they generate the new positions. Why? Because while building one particular canal, people found some routes, means low-level routes where water can flow to other locations as well. What they did at the time of building the particular, at the time of constructing the particular canal, they have given the dot-wise possibilities, means by knocking the dots on the particular map possibilities. If the water flows with maximum rate up to some extent, the canal may be damaged and the water may flow in an underway. So this we have to analyze. But at the end of the resource, the farmer is eagerly waiting to release the water for his fields. But water is not reaching. So immediately, what the central authority took the decision. Then let us examine why the water is not flowing towards. Started analyzing the same by deploying the drone. Then immediately proper precaution can be taken like this. So sometimes we are hearing about in a pipeline the water is leaking, or petrol is leaking, or diesel is leaking, gas is leaking. How this is happening? Like the way, yeah, a kind of requirement we require. So finally, that I'm not going to speak about the technical terminology here. Finally, get the global based solution for the problem and update memory for each row, means for each option. So let us find the possibilities at this moment, and for this year at least, yes, for this particular canal 4, at 5 stages, at 5 places or more than 6 places, the damage has been occurred. So identify them. Whenever the possibility of water is releasing in a proper way, the spots can be taken care. Excellent. So what do you require more than that? You tell me. So real-time monitoring is happening here. So this is the way to validate and mold a particular type of ML approach into real application. Yeah. This model consists of 3 parts. We know, without moderating and without optimizing the situation with respect to the modality of a mathematical equation, we can't. And we have to consider various constraints. And as I told you, we have to consider non-negative constraints and all also. That negative constraints must be kept aside and will be analyzed time by time, but we must and should have a kind of vision towards if something goes beyond working of the particular application, in the sense some negative thing is happening, my dear friends. So we must be able to ready to make the environment functionable, or application functionable, or IoT device functionable, like this, right? So a kind of objective function has been acquired here, right? That I'm not going to discuss about. This gives some feasible solutions with respect to R. Finally, what kind of attributes have been considered here? That cost of canal water, cost of groundwater energy, and cost of human energy. See, the damage happen in a particular canal, through a particular canal, is giving the possibility to flow the water in a maximum speed. Then if 2 humans are involving, then how many times or how many pouches of sand can be arranged immediately to stop the water? So human energy also matters here. So at least as a precautionary metric, the central authority will give the instruction to the farmers. Due to this monsoon situation, so damage may happen in future. So be ready with the possibilities, all the possibilities like this. So this is a kind of precaution we can give, or otherwise we can frame an alarm, or we can arrange an alarm nearby pole of the particular power station, or by deploying other kind of power resources like this. So in this way, the algorithm, in this way, application can be analyzed. Right. So finally, study area of existing seasonal crops have been performed. That rice in the Kharif season 10.41 and Rabi 0.31, like this, ragi, maize, wheat, bajra, tur, and Bengal gram, like this. So these are the functionalities of various crops being considered with such kind of modalities. I do not know. Up to some extent that we tried our level best to moderate the objective function. But even in future, you may choose your own way to optimize the same. Who knows? Then your optimized objective function may give better values as compared to me. Yes, this is also applicable. And then how? Then Maruti started with 800, and then today we are enjoying various variants. How this is possible? So moderations have been occurred, moderations have been done, and the technical things have been considered time by time by checking the non-negative constraints and negative constraints. Finally, they are making their business popular. Simple example. So this way that we can we can moderate the conditions. Yeah, the maximum of the objective function is subject to the following exit. Sorry, following has been done in a typo, tab typo mistake manner. Sorry for this. Yeah, following constraints. First one is that cultivation area has been considered. Cultivation area used should not exceed by allocated area. You know what happens if the cultivation area is exceeded by the allocated area? What happens? Then the usage of resources will be increased and will be wasted. Okay, and crop area, and finally a kind of various non-negative and negative constraints have been considered. And as we know that we cannot simulate and we cannot accumulate the possibilities of meta-heuristic algorithm in a simplified manner, that running a program on a single machine and saying that my algorithm working fine. No, this is damn wrong, my dear friend. So some kind of functionalities in terms of benchmarks have been defined with possible extents. So all the functionalities must be tested with any kind of meta-heuristic algorithm, so that the feasibility of the meta-heuristic algorithm can be analyzed properly. That's what. Right? Best example. Let me consider one parameter, that is a 100 meters race parameter with two constraints. The first constraint here is that a 24-year-old guy and a 64-year-old guy. Excellent. There must be a difference, you know. Obviously, 24 years guy can achieve. I have doubt about 64 age guy, like this. So a proper benchmark is required. Even 64 aged guy can reach the destination 100 meter, he can run, but the time taken for reaching the destination must be validated with the proper one. So 100 meter one, 10.11 seconds, Usain Bolt record something. Then that is a parameter considered. Then that is unless that 10.11 is achieved, then only we can say that yes, this guy is the top. In this scenario, again, gold medal will be given. So this is the benchmark functionality like this. So it must be validated in a proper way, right? For this, various 10 benchmark functionalities have been considered with respect to the literature, means with respect to the scientific community measurements, and the same has been tested. And finally, we found suitable up to the range of iterations. Up to the range of iterations. In future, some person may take the algorithm for his or her own experimentation part. this can be done. Yeah. So the results that I don't want to discuss more in a different way. So these are the option results with respect to this one. So conclusions for a while. An optimization model is outlined for land allocation to different crops in the Karnataka state of India. They have considered with the previous existing cropping pattern and objective model uses constraints with available land and water in different seasons of the year. So 26 crops are analyzed from 2010 to 2014. See, the area we have, the time constraint is also limited, 2010 to 2014. You may ask me that why don't we consider from 1990 onwards? Why? Because the environmental conditions were different. And this is for partial study only that we have tested till 2021 quarter, working fine. So the data analysis shows that most of the existing area is occupying by the rice, blah, blah, blah. So they consider as major crops in Karnataka, and given the possibility for the farmer to utilize the maximum agricultural land. So the allocated area of the existing crops for the rice, maize, sugarcane, and wheat was expanded slightly. The use of groundwater tube wells is increased for agricultural land. So in this way, the concept of ML paradigm 1 has been explored, my dear friends. Yeah. So I'll give you sufficient time for noting your questions. Please wait. Meanwhile, let me introduce another paradigm for precision agriculture. So this is for irrigation. So the first ML paradigm we have analyzed and validated with respect to the crops, with respect to crop planning by considering some limited area of land. But the land is completely depending upon the resources like water, like irrigation. So let's see that how the same can be optimized for best agriculture practices. Yeah, in this I'll be introducing a new concept. A new concept in the sense of a kind of integration part. Okay. Yeah. Precision agriculture, why the motivation, means what kind of motivation, what are the challenges and objective, then a proposed methodology, sample results, and conclusion for your reference and result. Yeah. As you know that PA, precision agriculture, is an approach to farm management that uses information technology. Lab has come to the real practice now. Right, so we are going to mold the information technology in terms of both, that is hardware and software, to ensure that the crops and soil receive exactly what they need for optimum health and productivity. So the goal of the precision agriculture is to ensure profitability for the farmer, sustainability and protection of the environment, as usual. So how can you say protection of the environment? Say if something is happening related to a particular crop and not that particular crop, and what the farmer did, farmer started spraying more than, extra count of pesticides. Ultimately, there will be an environment damage, land damage. So the next crop will feel a kind of different sustainability. Yes, so this way, let's see that. Yeah, need for efficient smart agriculture model, why we require. So as I told you, according to current growing and consumption rates, agriculture experts expect a 60% of shortfall in crop production by 2050. And the weather analytics, as per the weather analytics, 33 percentile of worldwide GDP is affected by the weather, my dear friends. Right, let us examine the possibilities. I'm not speaking in words. These are the real things need to be accepted in a form of reality. Right, yeah. So with the help of a kind of data analytics, I'm not mentioning, a kind of IoT type of design and machine learning algorithms, the crop productivity can be increased. So integration of something. Right. In the other part, then if I speak about the computation part, we require two things, that is storage and retrievability with respect to the network, based on the network speed. So what we require ultimately, we require faster analysis, optimized analytics. So that we guys termed in the name of in the form of big data analytics today. And what is the concept of BDA? Again, conventional mathematical approaches, nothing new except the technology, storage technology, and optimizing storage formations with respect to the memory taking place in a cloud or somewhere. That's it. right? So what it comes under, like data storage, data processing, and data analysis with accuracy. Hence, its use in the field of agriculture can benefit farmers and nations for economic growth. Okay, these are the requirements. So the challenges, what till today? Why? Because our farmers are our productivity mechanism, a crop productivity mechanism follows traditional practices, right? Because of this reason, no proper data acquisition has been done. Irrigation has no proper data acquisition. Irrigation system has been streamlined based on soil and weather condition. And there is a mismatch between problem statements. Like if I say that people say 100 hectare land has been considered for cultivating or cultivating as a rice crop. So a mismatch. Then yes, 100 acres is given. Then what is the condition of the soil? How much water resource have been released? And what is the utilization? And what is the productivity? All need to be considered. See, if you provide all these in one pocket and give to the farmer, then the farmer can do wonders, my dear friends. Okay, so again, if we speak about on the other side of the coin, that farmer is lacking in something, that is lack of skill of upgradation and training programs to update the knowledge and skills of farmers. Okay, so let's analyze. So for this, what we did, a GA optimized fuzzy inference system for policy recommendation in agriculture. Simple combination of GA optimized fuzzy inference system. So these two are not new, but we took the integration, means responsibility of the integration to perform something. So I'll try to memorize the same by conveying the exact policy methodologies, means policy type of methodologies, so that the policy type of methodologies can be utilized for best practices. Okay, yeah. So the objective is basically that I'm not speaking that please consider the last third point. However, the farmers are not benefited by the policies provided by the government. Yes, government is giving up producing, means formulating lot many policies, but these are not streamlined. Why? Because at each and every level, the people started backing the same. So nothing is reaching towards to the farmer with exact and moderated steps, right? So the potential impacts of global warming led towards the water adaptation measures must be considered to ensure that water is available for food production and consumption. Even 40% of our farmers do not know, really do not know that how the irrigation system has been framed out. If we speak or consider the concept of out of box, they simply wait like this. Yes, water will come someday, and the same can be given to the crops. Still, they do not have a set of modalities, like this is a particular time and this much of water is stored in the particular dam, and this is the releasing time, and the flow rate of this particular water from the dam towards this canal is this much, and based on the flowing water to the dam, this much of water can be poured. This we do not know, except some urban areas. Right? So to address this issue, a policy recommendation system is developed. Yeah, for this study, that this study we had performed in Telangana, I believe. Okay, I took the data from the station of Agriculture University of Hyderabad. Yeah. So the land of farmer, this financial condition is, say, land of farmer is 1 to 3. This is low, very low one we had considered, 1 to 3 lakhs of hectares, and 2 to 6 lakhs of hectares, and 5 and above high. Financial condition is from 20,000 to 60,000. Okay, investing. And here for medium 150,000 to 1 lakh, and for high 5 and above, 5 acres and hectares and above, 1 lakh to 1,50,000. So what is the attribute here? So for crop, water requirement required cotton, potato, tomatoes, and citrus fruit like this. Soil type is we require loamy, sandy for high. Rainfall is required for low, 400 to 600 millimeter. Here 600 to medium, 800 millimeter like this. And drip irrigation. Excuse me. Drip irrigation is required. The cost is 22,000 to 15,000. This is very less, 1 to 3 hectares. If you arrange for a while, the same can be. Why the government is not taking the responsibility? 22,000 rupees, very less, drip irrigation. And for medium, 2 to 6 hectares, 52,000 minimum. And for high, that is 82,000. And micro sprinkler, 20,000, very less, even as compared to drip irrigation. So 20,000 and 40,000 and 80,000. Why not? Right? This is lack of information. Okay. Yeah. So what we do, we try to optimize such kinds of strategies by considering the genetic algorithm approach, and maximum up to some extent that I'm not going to speak about. But let me introduce that in what way the concept of the modality of genetic algorithm has been modeled. What we do, the steps are like this. The individual chromosomes with higher fitness function are selected for producing offspring of the next generation. Crossover, the two chromosomes based on their fitness are scores are selected and are combined as usual. And mutation, this we know. So these are the operations we supposed to perform with genetic algorithm that everyone knows. Now, how the concept of fuzzy logic is combined or integrated with that. Okay, why we have considered this one, I'll let you know. This is suitable for handling different types of data sets that are vague and imprecise in nature. Yes, even you can do with other type of algorithmic approaches, but the computation will go in a different way. Even it may produce the suitable result, but it may take some time. Okay, or it may take some utilization of other parts as well. So what this fuzzy logic system considers here, there are three types, that is linguistic variables in terms of what I let you know, and a kind of function and fuzzy rules. The data of the attribute is divided into different parts, not as a common, and the linguistic term is assigned based on the range of the numerical values given. It is very easy to moderate because of that reason. And membership function to present the association of data point with any linguistic variable, and this function is assigned usually in the range of again 0 to 1, and this is a real value that describes the degree of belonging related to the particular term. Yeah, and finally rule we know. If then logic, simply the rules are usually written using if then logic only. Yeah, and this part represents the antecedent or the input, and then part represents the consequent of the output. So these are the gainings from fuzzy logic, guys, as usual. Other parts of steps, if you consider, fuzzification, what we do, all the crisp data points, crisp data points means solid one, means constant one kind of data points are assigned with a degree of membership with respect to fuzzy set using a membership function. Right, so the same can be modeled in a ease manner so that the available data attribute or point will become flexible for computation. Yeah, so application of fuzzy operators are antecedents. This is one type of possibility. So this is maintained in terms of fuzzy operators such and or is applied to get a single value consonant result. Simple. Yeah, implication, and that implication checks the degree of the correctness for every component of the antecedent. So these are the various types of operations. And finally, after completion, we perform defuzzification also. As a result, the name implies this process is used for what? That is converting something into back. So this is the advantage of the fuzzy system. That the hardness of the fuzzy. Yeah. So how this works basically, that how we are going to train the model. The attribute selected like the financial condition of the farmer, the crop which he grows out of 4 crops selected for model preparation, soil type of his farm, and the rainfall predicted. 4. Okay. So all the non-numeric values like sand type and soil variety are converted into numeric form for calculating the membership function. The entire data set is normally in the range of 1 to 10. Okay. Each attribute range is divided into 3 linguistic variables using triangular membership distribution. Again, a mathematical term comes in picture. For training the model, a combination of all the attributes is taken and crisp output is generated. So the input of the training data is passed to the fuzzy inference system. That's it. and no rules have been framed in a new manner, and the system is already adapted, but we integrated the concept of optimizing the values of attributes converted into numeric form. That's it. Right. So what it says finally, so I let you know the representation in the form of input pair and non-input pair, right? While considering by considering the inference system in the form of its working fashion. So the working model is like this. Yeah. So if you see the right side part exactly, so all the possibilities related to genetic algorithms have been considered and validated, like starting from generate the initial population randomly, evaluation of fitness source of score of individual, then we know the formality of the same. So selection of genetic operator, selection of parent chromosome, crossover, mutation, and copy into population set. This we did. This is the one. So after performing the same, the optimized value, see, excuse me, my dear friends, the optimized value is given back to the fuzzy inference system here. So after input, generation of training data and initial membership distribution, what happens? Then the desired variables will be given to the same, and finally the optimized value will be reverted back to the system. Then the fuzzy inference system takes care everything about the knowledge-based design variable, what kind of variables have been considered, with what kind of values, and what is the moderated value of the particular attribute, like soil type, whether the based on the soil type, that what that how much quantity of water will be given in a particular spam by considering hot condition, or what's that, humidity type of condition, blah blah blah. Yes, so these all values will be optimized in a generalized and normalized fashion. How easy it is for us to do. Very easy, no? Once we know the system, the same can be modeled, and this is the way of validating a kind of ML paradigm. Okay, so finally, there may be a chance that I cannot say that system works fine, excellent. No, there may be a chance. There may be a chance in terms of what? In terms of optimizing. If suppose if I say that even the humidity type of soil is found, okay, but no crop is planted, so that space must be ignored. So that kind of error may occur, and the possibility of optimization, the possibility in terms of optimization can be feeded by performing genetic algorithm with an ease of calculation. GA, excellent one. Even you can do. The calculation is quite simpler, and it takes limited number of iterations in managing the activities with respect to individual attributes. It's very easy, right? Right. In this way, the functionality of GA for the inference system can be established. Yeah. So how the fuzzy inference system is prepared? Okay. The first step in the system is to normalize the data set as usual. So keeping the values as you know, what is the soil type? Soil type 1, low me. The value is say something 0.2. So that values have been integrated in a min-max normalization, right? So table 2, I'll show you the converted the range of 1 to 10 using min-max normalization factor. For the soil, type rating is given on the basis of sand content present, and for the crop on the basis of water and temperature requirement. Yes, if the temperature is high, then the water will be feeded as usual. For say if I consider the rice or something, then the water is required in a more suitable fashion. Why? Because the water will be evaporated, no, based on the temperature, right? So once the attribute values are normalized, linguistic variables are assigned as shown in table 2. I'll show in the next table. So in the next step, non-overlapping crisp set is formed as shown in table 3. Non-overlapping, say just now I told you humidity is maximum in the soil, and that kind of soil cannot be utilized for a kind of crop. So the water requirement must be analyzed, right, based on that one. So it's a kind of non-overlapping crisp value. To form the training input for all the attributes, all the possible combination of low and high values are formed likewise. And finally, the documentation can be prepared in the form of methodologies represented. A simple one, I'll show you. Yeah, this one. So the normalized data when the land low, the values are 0.4 to 0, medium 2.5 to 7, and high is 5.5 to 10. So what is our range? 0 to 10. Financial condition has been modeled in this way. A crop water requirement based on the type has been modeled in this way. Soil type modeled in this way. Water requirement modeled in this way. Output sprinkler, none, and drip irrigation. Sprinkler, none, and drip irrigation. So these are the requirement with respect to the conditions of soil and others crops. Okay, and this is for non-overlapping. Say, my example, if I, for example, a land type of farmer, say type of farmer have been considered. The land type is a loamy. Okay, it requires only 1 to 1.5 range of value. If it exceeds, then ultimately the crop will be in trouble like this. So all related conditionalities with respect to the soil and water requirement has been analyzed. Yeah. How the GA works based on FIS optimization. This is an important part that I'm not going to speak about mathematical function, but let me give that the GA requires encoding the target variable phenotype, in the form of chromosome, that is genotype, for optimizing through GA operator, crossover and mutation. Yes, the 3 linguistic variables of land attributes are represented by the first 15 bits of chromosome, like 1 to 1 up to 3 for each high, low, medium, and high linguistic variables. The number of bit assignment to each linguistic variable is determined by real value encoding with binary code, RABC schema. That's it. And this is employed to derive a binary string of length something, and the length has been calculated, which is represented in table 2. So the values have been opted. Yes, this functionality that I don't want to discuss, why? Because this is mathematically related functionality. Yeah, the possible combination of output low and medium and high are represented by 2 bit, like low to 0 and medium is 0, 1, and high is 10, as I told you, 0 to 10. Hence, the possible bit requirement for consequent representation for all possible rules in the rule base will be up to 486 bits examined, very less. So the seeding of initial population is based on continuous uniform probabilistic distribution, and the probabilistic distribution over a given interval is calculated by using this functionality. Simple. Okay. Yeah. How the with respect to that one, how the crossover and mutation has been managed. Why? Because the concept of GA is included with rules of fuzzy, So if some error occurs, then the optimal conditions will be fixed. What kind of optimal conditions? Like related to fitness value, related to crossover, and related to mutation type of operations, right? So what it does basically, the crossover combines 2 chromosomes to produce a new offspring, which inherits the property of the parent chromosome. This we know as usual, right? And the concept of mutation is achieved by performing the bit flip operation 1 to 1. The approach flips is each bit of chromosome with a given probability and mutates the given chromosome. This is the actual happening with the algorithm of GA, right? So if you look into the concept of experimental outlook, the evaluation part, how it is tested, right? The evaluation of the proposed is based on the recommendation or that is FIS, fuzzy inference system output measurement for a given set of test input. Okay, so the GA based optimized membership function for attribute financial condition, land, crop, water requirement, and soil type is presented in upcoming figures. Okay, the optimized solutions were obtained after 500 iterations or generation of genetic algorithm approach based on the feasibility of the algorithm. Nothing is new. Nothing is new. Thus, we have optimized the values and changed in the required parameters and performed crossover, mutation, and the related operations of GA. And finally, the values are submitted back to the fuzzy inference system based on the frame rules. Yeah. The output of regular interval for of 10 was recorded and presented in figure 5 in upcoming one. As usual, mean square error has been calculated. Right? This we know. Right. Some key observations I'll let you know. What happens, the fitness value evaluation of individual chromosome is based on mean error calculation between test output and FIS output. Test output is from GA and FIS output is from fuzzy inference system, which is given in some upcoming picture. Further, we analyze the error in final recommendation. Since the conversion of Chris value recommendation is based on mapping, no output of predefined range presented in table 2 means out of order, like what humid type of soil and no plant. So what kind of water requirement is there for upcoming plant, that we need to choose. So in the format, in the format, the MSC value has been opted. And yeah, from the analysis, we conclude that the optimization of FIS using GA approach via linguistic variable triangular membership function parameter tuning improved the recommendation processing capability of entire model. So this may happen individually. Right. The combination of optimization can be performed individually, but when these two concepts are integrated, the computation became feasible and recorded less time, very less time. Okay, that we can perform individually with two different approaches, doesn't matter. But we require a faster mechanism. Because of that reason, the integration has been done. Has been performed. So like this, for financial condition, land, crop water requirement, soil type, the individual output with respect to the FI system has been generated, right? And the contributions declared for R. This study is recommended for irrigation policy to the farmers based on the environmental conditions. That's it. The crop grown by the farmers and the farmers' financial situation. The new technology adopted in terms of fuzzy inference system based recommendation system help farmers select appropriate irrigation policy, like from drip irrigation or sprinkler irrigation, according to their needs. So this work will definitely make an appropriate decision during the selection of all. Okay, so likewise that we have validated two different ML paradigms for agriculture field, my dear friends. Now, this is up to the industry of IoT. Why? Because I'm not a electrical background, electronic background, or instrumentation background candidate. I do not know, or even I do not know the strategy of chip designing, but I know how to write a program and how a program can be embedded into that. This is very easy, right? So in this fashion, the methodology of ML paradigms can be validated for further usage in various applications, like starting from agriculture, financial, and even healthcare also. Okay, so that's about the contributions today. So I'm inviting questions from your end. Please do let me know. Any questions? Yeah, please. If any questions, please do let me know from your end.
Yeah, so I invite question from the audience. Any question or any kind of the this thing, the sir will give the answer to your query, sir.
Yeah.
There is one question from the Bharat Kana. On what basis the rule are formed?
Yes, please.
There is one question from the Bharat. Based on what the rules are formed in that low, medium, and high, and how the value are chosen.
So your voice is not much clear. Please.
Okay. Sorry, sir. Am I audible, sir?
Yeah, you're audible. Please, please.
So there is a question regarding the how, on the what basis the rules are formed in that low, medium, and high, and how the value are chosen. In the you convert the some data about the water and the rain in the numerical value. So on the what basis you have chosen that value, and how the rules are formed. That is one question from the.
Yeah. How the rules are formed? Yes, yeah. Based on the situations, like great, good question. So this is the first rule declaration, right? So even say if you have your own opinion, no, like say. Good question. So this is the possibility and greatness of fuzzy inference system, right? See, I have some common feelings about one object. Okay, say example like the water bottle or like the iPhone. I have some common feelings about. If I feed these 20 feelings, the commonly correlated values can be extracted. Commonly correlated values. Say in my sentences, I have mentioned, hey, iPhone X is good. First one. iPhone X is good with related supportable and supported applications, right? Again, the applications in the iPhone are quite secure. Like, see, so sometimes something is repeating. So what I mean to say here is that the hardness of this particular sentence will be hardness. Based on the hardness of the sentence, the value will be molded in terms of considerations. So if you take the example of crop, right? Let me consider about say cotton crop. Okay. Cotton crop may feel different types of or may acquire different types of diseases while growing. Say within the 30% of its growing, right? Say 5 major diseases may occur up to some extent. If these diseases may be due to the giving the high volume of water or something, or giving exactly low volume of water. See, all these kind of functionalities are feeded. So if I say if the 10% growing stage, the water capacity must be this much. Okay, and at 12% growing stage, the water capacity must be this much. So along with water, if something is happening along with water, some kind of disease is growing, again the water levels must be decreased, and a required percentage of pesticide will be sprayed. So these are the predefined values we are submitting to the system in the form of root. So the system will optimize. Here the values are not taken in a different manner. Why? Because the values have been retrieved from the existing database, fixed database. Say example, for fever, I'll take what, paracetamol. I cannot take azinthrol, right? So like this. So this is the knowledge given, feed it in the form of values to the system. So based on that one, the inference system will be made. Yeah. Yeah. Any other question?
Yes, sir. Yes, from the audience, any question? So, one more thing, sir. You have addressed the pro search algorithm for the issue regarding the food.
Okay.
So, is there any other kind of the application where we can apply the pro search algorithm, sir?
Yes, lot many implications are there. So even individually, if I work with CSA, up to some extent, I can find the best maximum, best global value. Okay, means the range of the particular flow based on its memory. The range of its flow based on the memory of the particular crow, that we can maximize the value. But again, another implication can be done. See, choosing the best global value requires the concept of optimization. So you can increase optimization by clubbing another optimization strategy with CSA also. There is a possibility. Yes, implications are there.
And sir, you have addressed one of the issue regarding the we have facing the India. There is a food issue and the irrigation system that our farm because of the limitation on the environmental side, and it is not our farmer and our system are not coordinated very well, and the lack of the information about the farmer regarding the type of the crop and the type of the condition of the our environmental. So this is and this kind of the issues. It is also addressed in the National Education Policy 2020, and we are very happy that you have given the new direction to the our audience regarding the how the research and how the machine learning and AI how can be used to find out the new kind of the solution to our requirement to our farmer, and this will help us to increase the income of the farmer. It will solve the many issues about the farmer and the need of the today's regarding the food lack of the food in the many parts of the India, and this will also help us to our interest about our need. And there is a one. So we are very thankful and we are very lucky to listen from your finding, your way of the research, and I think that many of us will contact you regarding this kind of the solution for the other part of the India. You have taken the case study of the Karnataka and the Telangana, and I am sure that we have the variety of the person from the all over across the India, and the same kind of the work can be implemented in their area, like Gujarat, like Haryana, and Pune. So there is I think this is a very good kind of the application or solution based on the machine learning and the artificial intelligence. So we are very thankful to one. And there is one question from the Professor Dr. Chandas Vitsrani sir. The question is the basic difference between the flow search and the cuckoo search algorithm, with the one example of the agricultural application like water canal or any other. The basic difference between the flow search and cuckoo search algorithm. So, there is one question from the Professor Chandas Vitsrani sir. So there is a question from the him sir. Hello sir.
Hello. Yeah, please.
So the question is the basic difference between the crow search and cuckoo search.
CSA and
See, cuckoo.
oh yeah. Fine. Yes, I got it. Good, this algorithm. Fine. See, yeah, great. Good question. See the modality of an object. See, a kind of mechanism has been molded from the modality of an object, and this Google Sheets algorithm works in what kind of fashion? Do you know that? So this is based on the knowledge provided. So that's what the mistake was happened. The guy who was searching for a fixed location, he went into different location. Right. So the difference here is that is modeling and considering the feasibility of flow direction in the path. Flow direction in the path. See, based on the constraint and the problem chosen, the optimum solution with respect to CSA has been provided like that. Right. If I could have chosen the CSA for another problem in a different manner, then definitely it would have been given in a different approach, right? So what I mean to say is that the optimization strategy is problem dependent. Okay, problem dependent. This is the answer for that. Simple reason.
Okay, sir. I think the Professor Chandas sir take the note of the answer of yourself.
Okay.
Any another question from the audience?
Yeah, please, if you.
We have a couple of the minutes to end this session. If there are any questions from our participation, they can write on the chat box.
Yeah, please, if you have any specific questions, please do mail me at drramesh@iitism.ac.in. Okay.
Okay, sir. Right now, there is no query regarding anything, sir. So, any query, the participant will connect you by the email or any kind of way of the communication. So this
Okay.
is I am very happy to listen to your finding, and my area of the working is in the somehow in the same manner. And I
Good.
will contact you in this regard for the
Yeah, sure.
further kind of the research in the this area, sir. And
Yeah, sure, sure, with pleasure.
yeah, thank you, sir. So this is a
Yeah.
behalf of the GTU, British School of Engineering and Technology, and the Center of Continuing Education. I am very thankful to giving sharing the your research
Okay.
and giving sparing the some your valuable time for the our participant.
Fine. Yeah. What I mean to say is, see, we are academic community and a little bit research we propagate. See, nothing is different. I mean, nothing is bad to learn about. See, so we supposed to learn by accepting our mistakes. So knowledge and learning is not gaining knowledge and learning is a continuous process. Okay,
Yes, sir. Yes, sir.
right?
Yeah.
Tomorrow I may come with a different finding. Who knows, right? So like this. So this
Yeah. Yeah.
is a kind of help in the form of knowledge sharing. We can do it anytime, my dear friends. So I'm always available for academic type of academic related issues. Please contact me, and my profile is publicly available in the www domain. Okay, great.
Okay, sir. Okay. Thank you.
Yeah,
Thank you,
fine.
sir,
Thank
very
you.
much.
Thank you, guys.
Thank you. Thank you, sir.
Yeah. Thank you.
Thank you, sir. Professor Gautam Apana, coordinator of the coordinator of the FDP, online FDP on the Internet of Things with the machine learning and artificial intelligence. So today we have the second session for the uh, this FDP day number 4, and we have Dr. A. Chandrasekhar Rao from the IIT Gujarat. This topic is the soft computing in bioinformatics application. So, on behalf of the GTU, British School of Engineering and Technology, Ahmedabad, and the Center of Continuing Education, NIT Warangal, I welcome Dr. A. Chandrasekhar Rao for this session. So, as a part of our tradition, I just introduce this brief profile of the Professor A. Chandrasekhar Rao. He is assistant professor in the Department of Computer Science and Engineering at the IIT Dhanbad from the last 20 years. He completed his doctorate degree in computer engineering from the IIT Dhanbad in bioinformatics. He completed 2 research projects based on the machine learning. In his credit, there are the 1 patent, 2 books, 4 book chapters, and more than 50 research papers uh, published in the renowned and the peer-reviewed international journals. He is member of the IEEE, International Association of Engineering, International Society of the Computational Biology, the Society of Digital Information and Wireless Communication, Institute of Electronics, Information and Communication Engineering. So this is the brief idea about our speaker, Dr. A. Chandrasekhar Rao. So I just uh, hand over this session to Professor A. Chandrasekhar Rao for his research on the our main theme area on the machine learning and artificial intelligence. And we are very happy to listen to Professor A. Chandrasekhar Rao for their uh, research point of view on the bioinformatics application. Over to Professor Chandrasekhar Rao. Sir. Am I audible? Yes.
Yes, yes. Yeah. Thank you, Professor Gautam. Hello.
Yes, sir. You are audible, sir.
Yes, yes. Fine. Shall I continue? Everyone
Yes,
is
sir.
ready or anything?
Yeah, you can start now.
Fine. Okay. So, welcome to all of you for this session. Today, my topic is on artificial intelligence in bioinformatics, or let it be in soft computing in bioinformatics. So, before going to the uh, so whether the slide is visible to you, or
No, sir.
yeah, I
No sign is there. You have to.
let me yeah, me no, no, so present, yeah, I need to present, right?
Yeah. Yes.
So where is this? Not this one. So where is the presenting option where I can give the
Near the camera tab, there is a screen, and if you just click the screen, then the sharing option will come.
near the camera?
There is a written the screen tab. The icon is there for the screen.
Yes, fine, fine, I got it.
Thank you.
Now the screen is
Yes.
visible.
Sir, yes, it is visible now.
Okay, fine. I'll make it full screen. Full screen mode. So I think screen is clear to you, all of you,
Yes, sir.
right?
Yes, sir.
Yeah,
Yes.
fine. So this is my topic. Let it be AI or soft computing in bioinformatics. Both are a bit. We use soft computing, many of the soft computing techniques in AI for optimization. So some of the contents or some of the things I shared is from that. So my topic presentation, like what I cover in this presentation is, will briefly go to try to understand the AI and its applications, and also bioinformatics, and various application and challenges of AI in bioinformatics. With so wherever the possibilities are, let us explore, and also IoT for healthcare. So this is one of the important things nowadays, since we are in pandemic situation. Using IoT device in healthcare is one of the emerging research field. Let it be mm, related to using robotics by using IoT sensors and other tools in the healthcare domain. Not only that, we also can use this IoT in various aspects, like even pharmaceutical industry also, for speeding up, and for certain places where the humans are restricted, we can use different sensor for healthcare and pharmaceutical domain as well. So we'll try to explore a bit, and so maybe um, how far we can cover this class, I don't know. So due to my limited time, so I can take up to 12, 10 or something like that. I have other busy schedule as well. So I am trying to speed up. So I may go a bit faster. If I am very fast, you please let me know so that I can stop and I can explain in that. So yeah, coming to the AI. So everyone knows John McCarthy without his name. So we are actually AI the term. We don't know AI the term, because John McCarthy, he coined the AI term first in 1955. So during his one of the conference, Dartmouth conference, which was held in Dartmouth College. So that's a kind of summer internship or a workshop or like that they have organized. They have invited more than 40 to 50 people. They gathered over there. They have brainstorming sessions on different aspects like how the computers can think for different problem solving. While they started working on it during this conference, so they started using the term. So this uh, artificial intelligence at first. After that, so the we know where we are using this AI also everywhere most of the fields. So even if you touch anyone, they will say AI. When they are submitting research projects, they are trying to incorporate artificial intelligence aspects. Let it be for image processing related, where they can apply optimization techniques or certain kind of analysis. Everywhere they are using the term AI nowadays. Without the term AI, let it be even if not direct AI, they may use deep learning or these uh, terms usually we hear from everyone. So what is this AI? Actually, the main intention for the AI is usually this is with the aim of think like people. Maybe not exactly like imitating exactly human, but certain tasks which usually for the logical thinking or certain aspects. So what usually people think, the similar way the computer can think. So how the computer can think? We use certain technologies. There the AI is the behind it and think rationally. So sometimes for say taking certain decisions, uh, for thinking rationally, we use the AI based machines. And also so act like a people, so like a robots, we are using robots, everyone, even so we have many examples of robots where we are using not only just industrial robotics. There are many places where we use robotics. Even nowadays in corona time, we are using robots just for uh, getting the data from the corona patients. Let it be temperature, taking the temperature from the particular patients, are getting the data of them and knowing the situation over there. And even for sanitization, they try to use different robots for uh, uh, using these machines, like act rationally, when to respond, when to not respond. Those are the things that's very important in AI. So we have like these are the some of the broad domains where we use the AI for predictive analysis. There, let it be deep learning or machine learning. We use it called predictive analysis. And for text to speech, like the speech to text, this is speech processing. Means AI can be used in machine learning, which comes under both predictive and deep learning. And whereas the speech analysis, we use text to speech and speech to text. There are many places we use this text to speech and speech to text. Now, it's not only for just the like the one who is not able to hear, but in some applications we need to convert the text from one to the other as well, like taking the data and we use a combination of both the speech and NLP together for making different analysis or different results as per the need of the particular problem. And we also use the image processing or the computer vision in terms of machine vision or image recognition. And we also use NLP such as classification, text classification or translation, data extraction. Even we have another domain of AI, that's expert systems. Like earlier days, we have expert systems like MyScene, where they used to. It's a kind of MyScene is a kind of expert system where it try to use to help the patients and doctors in such a way that if something for certain decision is needed. So from the previous past experiences and the data, so they are trying to give certain like analysis. The mycin is one such kind in the healthcare domain. So not only the mycin, there are many such expert systems there available, and for planning and optimization also we can use artificial intelligence, just like scheduling of anything, let it be timetable or let it be any game schedules or anything that actually needs certain planning and where your optimization is essential. And as we already understood the robotics where we can use, so these are all the different applications. And if you see that in so in a different way, the simplified AI landscape looks like this one, and there are mass adaptation of these applications like chatbots. So nowadays we are using this natural language processing. The chatbot, what they are giving, like the messages. Just even this Corona time, also we everyone knows about these chatbots. So if you install the apps for knowing your by knowing your GPS, they will alert you the nearby. The particular application apps, chatbot apps are making you alert about the nearby patients or the corona the regions. So if you are surrounding to the so and so place, then it can give you some hints. So if everyone follows that one, those who are installed a chatbot, everyone have to be active. In that case, and their GPS should be on, and we'll definitely get some useful information from the chatbots. And there are like personal assistants like Alexa, Siri. There are many applications. Even Tay by Microsoft for natural language processing, and Autopilot by Tesla. So and there are certain main WATS and machine learning, speech recognition, and the speech processing apps. Deep dreams, where the neural networks are used. There are different applications for the simplified AI landscape where we are using, like even the mass adaptation of these applications. These are regularly used applications in AI domain in the industry, as well as some usually accepted uh, apps. Now, if you see where this e-commerce is used, AI is used in e-commerce. These are the top 7 e-commerce websites in India that truly depend on some of the AI and AI-based applications like Amazon, Flipkart. These are the list. And if you see the social network sites, these Facebook, Twitter, and all these things, Google Plus, all these examples they are using YouTube, all they are using AI-based techniques. And basically, if everyone is a Google users nowadays, everyone have different, like let it be YouTube purpose or maps, or let it be for searching or making your calendars and tasks, and even to maintain your photos, or even Google Sheets, online Google Sheets and document slides, and even for different exams like Google Forms. There are many, like even handling different your files in different Google drives, and accessing them and sharing it to different people. So everything, all almost most of these applications of Google are purely based on the AI. And basically, if you see the AI in computer vision, so if you see any location, they have to um, actually identify the particular portion, and then they will try to give this particular location, or the identified location is of what, whether it's a car or a person or a bicycle or like that. So we use the computer vision over there, and we use different image processing techniques to identify that, like sometimes we use segmentation, classification, and filtering. And so there are many ways of computer vision that image processing based techniques that we use over here. And even if you see in some places, so if you trained, if for example this is the image, in this image some people they have the numbers, you are able to see the numbers over them. So that is actually this is already data or label data, and this label data has certain features, and when it was trained, and the features are stored, and when the input data is given, and if they identify, so these images are given already, and they are given they are all labeled information. Labeled information is already held with them. If some image was given to them, then in the testing time they will identify, so whose image is this, the number, the labeled information. This happens only with the help of the features. They will try to grasp the features of different labels or the images, and then that features will help them to detect whose image is this. Likewise, we have plenty of applications in AI, and especially if it comes to the bioinformatics. See, bioinformatics, when initially when it was introduced, a group of scientists were asked to describe about bioinformatics. It's not just this same question is not asked to bioinformatics people. It's just like if you see this image, you will understand. So it's a story actually. It's a long back some story, and so some people they won't recognize it until they feel it and they touch it and they smell it or something like that. So when they ask to know about what it is, they some people somebody actually this is a story. If you see this story, this is a blind people story, and from that story this image was actually the story is related to like they are these blind people used to know everything if by touching it and by feeling by in different senses. By the different sense of organs, they will try to identify what kind of the new thing that is available to them. So they heard that some new animal came to the town, and so they want to know that one. So they went to that place, and they went to the animal, and they have climbed. Some people they on the top. They have touched some people for so just wherever they have touched the particular position, and they are saying that this looks like this one. This elephant, when they are describing about elephant, some people they said it's look like a horse, white horse. Some people they said by it's this elephant look like a tree trunk, and some people they said the elephant look like a barrel. Some people said palm tree. Some people some by smelling they will smell XYZ. And even the person who touched the tile probably you might told it's a rope. So from the story, so what we can understand is when the bioinformatics was introduced, the bioinformatics to describe about bioinformatics by different people, those who are trying to use the bioinformatics or those who were involved in bioinformatics. Some people they said it's like a firehouse, similarly like this means how they are using in that aspects. They try to say bioinformatics is this much only. This is the bioinformatics. And some people they are using for different other purpose. They will say the bioinformatics is for only for this. But in bioinformatics we use computer science, biology. Actually basically bioinformatics is to solve for the biological problems. That's main goal. And apart from that, so for solving biological problems, what we use simply only computer science? No, not only computer science. There sometimes we use physics, chemistry, and statistics. There are many things we involve. So if some people they are using simply statistics for some their problem, if they say bioinformatics is just it's, is used means statistics is used to solve the biological problem. That's not right. So it's a combination of all together. So even not only that, even the people, those who are actually involved from both the sides, bioinformatics point of view. So in the bioinformatics, these two people involved usually. These two groups of people. One is the people who involved in the wet lab, wet lab experimentation, and the people go other were in the dry lab. In the dry lab, they try to use the computational methods and tools, are the bioinformatics. Best we can say, the bioinformatics usually develop tools which usually used by the wet lab people, are also some bioinformatics like some people, they are those who don't know the tools, development of tools. Just simply they can use and they can apply it, and they predict some kind of biological analysis, bioinformatics related analysis, like whether the two given sequences are similar, or given multiple sequences are of what kind, and how the consensus sequence are, and likewise we have many things to understand over here. So even so, the two groups of people involved in bioinformatics. One is both dry lab and wet lab. Biology point of view. By wet lab people, they see at computer science people like they are doing X, Y, Z, like super ordinary things they are doing. And when the computer science people see about the biological people, they try to see they are kind of see and the jungle kind of work, and that I cannot understand directly, and they are so it's a different like from the both sides. But for developing bioinformatics tools, from the both sides, both the developers and those who are working in the wet lab, and this coordination is very much important for complete development and even for testing of the particular tool which was developed through different analysis and different aspects. Like here, why we use bioinformatics can be viewed as the use of computational methods to take uh, to to make certain biological discoveries. That's what we understood as of now. And so there are other aspects as well to discuss about uh, like some of the examples in the bioinformatics you see. We use bioinformatics for database making, different database and different interfaces for those databases. Just like for DNA, we use GenBank, EMBL, DDBJ, and for other Medline, we use literature. For the literature related database, we use the Medline, medical and literature. Both the aspects we use Medline, and SwissProt is for protein database, and PDB, protein data bank. There are many such databases, and there are various types of specialized database as well we have in the bioinformatics. This is related to the database interface point of view. When sequence alignments are concerned, so sequence alignments are the important analytic analysis in bioinformatics. What they do actually, when so you have used already existed samples or the records, and you just want to test the newly discovered sample, whether so this is already done by some people, how close to the already existed one. We need to actually study certain kind of comparison, some kind of like how close they are, how percentage of similarity, like the percentage of identity. So these things need to be identified to understand how close the information is related to, or the samples are related to. We use BLAST. BLAST stands for basic local alignment search tool. So FASTA, this is FASTA stands for fast all. So there actually for BLAST also there are 5 types of variants, and fast also there are 4 to 5 types of variants. And the what exactly they do? So they use actually certain heuristic methods for properly aligning, and the best to find out the best alignment among them, among the pairwise, let it be pairwise sequence alignment. So here in the sequence alignment, we are just trying to discuss about the two sequences, just for understanding. If comparing two sequences, that's a pairwise sequence alignment, we use both BLAST and FASTA. Whereas if it is more than two sequences, if we need to compare, we need to use the concept called multiple sequence alignment. So for that, we have the tools called cluster, multi-align, di-align. So there are many such tools available for multiple sequence alignment. Even through multiple sequence alignment, we also have certain understanding about phylogenetic tree analysis. Certain concept of multiple sequence alignment is used for phylogenetic tree analysis. There, they try to understand the the four parents are certain relations to the given sequences or the sequences that are under study. So, and apart from that, we have gene finding, protein domain analysis, like protein families, blocks, and proteome. Like there are many other aspects where we can use this bioinformatics, like protein identification or characterization. There are methods called Gibbs sampler, alignase, and MEM, and there is a protein folding or protein prediction. So where we try to predict the protein, its protein related secondary structure, tertiary structure, or quaternary structure, depend on the given input information. And likewise, if you go on studying about bioinformatics, it's a combination of all, like databases and CAD, computer-aided drug design, genomic, proteomic, molecular biology, like that. And but if you see the basic unit of different studies of bioinformatics, the DNA is the one of the base or the basic unit over there. DNA stands for deoxyribonucleic acids, and it's the blueprint of a life, any life, let it be human or any other species, living thing. And so it was discovered in 1953, and the double helix structure. And usually in the DNA we have the four bases, like the four bases are important for making the DNA sequence. That there is adenine, cytosine, guanine, and thymine. And when the pairing takes place, when the double helical forms its structure, A always pair with T and C always pair with C. Means T with A or A with T, or C with G or G with A. Either of the sides, let it be in the double helix, but A always pairs with T and C always pairs with C. So this is one of the important things that we need to understand. And when the DNA replication takes place, DNA replication in the sense from the DNA, the multiple DNA sequences will be made. Like, so see how the one of the strand out of this double helix, one of the strand comes to the one cell, another strand it goes to the another cell, and we try to build with the new 5' and new 3' so that then so we try to get the two daughters over here. And main central dogma of molecular biology is a kind of replication, DNA replications, like transcription, translation, protein, converting it to the protein. Means initially we have a DNA sequence, then we are converting it to the RNA, and then we are converting it to the protein. And so during this, the process of converting from DNA to RNA, it's called transcription, and the process of converting from RNA. So it's not simply RNA. So there are many RNA types as well, like messenger RNA, mRNA, rRNA, tRNA. There are many RNA over here in the after the transcriptions. Once you receive this RNA, it means after converting it to the respective RNA, so from that RNA only we will convert to the protein. Directly we are not converting from DNA to the protein. We convert from DNA to RNA. That process is called transcription, and from RNA to protein we are calling it the translation. This entire process is repeated for almost all the cells and almost all the this molecular biology. So that's why this system, this particular replication of DNA, transcription, and even sometimes from the RNA, so we will get the reverse transcription to know its DNA. So that we call it the reverse transcription. All this process like transcription, translation, maybe sometimes reverse transcription, altogether this is the main theme of molecular biology and various applications. So that's why it was treated as a central dogma of molecular biology. And if you see the basic units of this bioinformatics, we have the units like DNA, RNA, protein, sequence, structure, evolution, pathways, interaction, mutation. These are all different units, are different units of information that we use in the bioinformatics. So just like DNA, it's a genome sequence completely for a particular species. Let it be human genome, or let it be rice genome, let it be rat genome, let it be like any mosquito, some XYZ mosquito. Like we have all the species, right? So different species and their related genomes are the genomic related matter. It's a kind of DNA. And when the transcriptome means actually we convert that DNA sequence into that RNA, so that we call it as a transcriptome. Means we have the different combination of data sets, so the specialized data sets, and when the data is converted to the protein and we are handling the particular proteins and protein related information, that we call it as a proteome. The data that's related to proteins is proteome, and RNA transcriptome, and DNA it's a genome. And likewise, so if you see further in the DNA, so we have a simple sequence analysis like database searching, pairwise analysis. That's what we discussed in the pairwise analysis, like BLAST, FASTA, and those are the things that we used to do in the sequence analysis. And whereas the regulatory regions, we need to understand where exactly the regulatory, the particular, so in a given network, gene regulatory network. So where the important aspects like active sites are there, or the important aspects are there, and where to where it is controlling, from where to where it is coming, and these are the important pathway, finding the pathways as well. So there are many aspects that we need to study in this DNA related studies. And maybe sometimes gene finding in a given sequence, all the sequences are not useful, some sequence is useful. The useful sequence for converting it to the let it be protein, so that protein are the useful information of the genetic material. They are actually useful codons, like so we will understand what exactly we call them, like exons, introns, and so there are certain aspects. So we are going to go through them just after this slide. And there are comparative genomics, like analysis between species and strains also can be possible. The DNA looks like this one because all the sequence, the combination of this information basis, all is a combination of ATGCs. The sequence, whatever it is there, the DNA sequence, it's a combination of ATGCs altogether. And here coding or not coding, like here I have the given sequence. In this sequence, whether it is means it is used to convert to the RNA or not, means actually some are useful text and some is useless text. The useful text, which we are using it as a useful codons, are converting it to the amino acids later. So so in the process of making protein, we need to understand the coding regions and non-coding regions. And again, we have to parse into genes also, means converting into the proper genes. And for this, we are using the complete DNA information. We are using AGCT or APGC. So for in a protein, the information they look like all the 20-letter alphabets. So these are the 20 letters: A, C, D, E, F, G, H, I, K, L, M, N, M, N, P, Q, R, S, T, V, W, Y, and but not B, J, O, U, X, Z. Out of 26 alphabet letters, use the top A, C, D to W, Y, and but not this B, J, O, U, X, Z. So these letters are excluded for representing the amino acids. Actually, these are the letters we are using for the codon. It's like after converting from the DNA, the codons, the codons are three. Codon is nothing but a three-letter combination of the nucleotide bases. From that three bases, we need to make the amino acids. Once the codons are identified, that particular codon have certain amino name of the amino acids. We have only 20 letters that we are using for those amino acids, that particular codons and amino acids. So those letters are used for making the protein sequence. Means earlier we have used ATGC in DNA sequence, and in protein, for making a protein sequence we have to use 20 letter combinations to make the protein sequence. So so actually how it makes is, if you see the 4 letter, out of 4 letter, if you take all the 3 letter combination from the 4 letters, 3 letter combination in the sense you can, so for example A, if you take AAG is a one combination, T is another combination, maybe AAA is also combination. Likewise, if you make the codons from the 4 possible letters like ATGC, if you make the codons, all possible codons, they are of 4 power 3, that is 64. 64 codons are there. Out of 64 codons, actually the some codons are performing the similar way. They have the similar meaning in the particular amino acid point of view. So what we use is, and some are some codons are the start codon and the stop codon. Start codon and stop codon are used to understand where the coding sequence starts, and stop codon determines where the coding sequence stops. So here, so if you understand these, like out, other than these 20 amino acids, these 6 letters we won't use, and even the out of 64, the 64 will be converted to the 20. Converted in the sense, not converted, maybe out of 64, 2 or 3 are representing the same letter. Out of 64, for example, some codon number 14, codon number 34, codon number some 45, they may represent the same letter in the this 20 letter alphabets. That happens. That's why out of 64 you will get the 20 only. There are certain reasons for making this. So like for identifying the proper so sequencing, so we need only 20 amino acids, that is sufficient, right? So the 20 amino acids only we are using out there for making the protein sequence. Very important, this is a very important step in the bioinformatics to understand the bioinformatics topics. The first one is why the important sub-disciplines are the things that we do in bioinformatics. The first one is development of a new algorithms and models to assess different relationships among the members of a large biological data. That was the first one. Means we used to develop algorithms or models. And the second one is analysis and interpretation of various types of data, such as nucleotide, amino acids, sequences, protein sequences, and protein domains, protein structures. That's another aspect. And third one is development and implementation of tools to enable efficient access and management of different types of information. These three are the very important sub-disciplines. Meaning some people they develop algorithms, some people they analyze and interpret the data that is available, data in terms of maybe DNA, RNA, protein, or something like that. Development and implementation of these tools, actually these tools are used such as BLAST. So for example, as for today's discussion, we gone through BLAST. BLAST is used for pairwise sequence alignment, and similarly FASTA, and likewise even CLUSTAL for multiple sequence alignment. Some people, hello, hello, yeah. So yeah, there are other important sub-disciplines within the bioinformatics, such as molecular modeling, DNA sequence analysis, phylogenetic analysis, molecular dynamic simulations, protein sequence analysis, and even drug design. And as I said, when we are converting a sequence, DNA sequence to the RNA, so there are certain regions like introns are actually that are ignored during the process of transcriptions. Means introns are doesn't have the useful codons. And even if you see how they look like here, if the continuous data is consist of a sequence, there some junk code is there, and exons are there, introns are there. Junk and introns will be neglected, and exons will be used for converting from the DNA sequence to the the amino acid sequence or protein sequence. Both are same. Amino acid sequence are usually used to make the protein sequence with the help of the amino acids only, right? So from the given sequence, we also, from one particular sequence to another sequence, we use to convert, we make the genes. That is also one part. And there are many computational intelligence or artificial intelligence based methods that we use in bioinformatics. So these are all different methods, just like for prediction. So these are all list of tools that we use. For optimization, we use this list of tools, and control, we use this list of tools, control and diagnosis. And if you see the neural network concept also, we know how the neural networks works actually. It works, it tries to imitate the concept of brain neurons. So there, so we take certain inputs and certain weights to it, and then summation, and with the help of certain bias, our activation will work and it will give the output. So this is the way how actually the neural networks works. Even the deep learning also internally how they work. And when it comes to the neural networks, according to Aiken, so in 1994, the neural network is a massively parallel distributed processor that has a natural propensity for storing experiential knowledge and making it available for use. So this is one of the important aspects. Actually, why we use these are the two, like knowledge is acquired by the network through a learning process, and interneuron connection, strength known as the synaptic weights, are used to store the knowledge. Like when we are passing the information from to one to the other, the synaptic weights are used for how far I can take those values. That's very important. That based on the weights only, uh, the respective outputs will come. So here, if you compare the human brain with the computer brain, or let it be AI, is nothing but it is using computational methods and tools, right? So if you compare those, they are look like this one. So the only difference, most of them, element size, energy use, and even hedges, maybe processing speed onwards, they are actually a bit different. In human, we think parallelly, and whereas the computer, it works serially, centralized, and also fault tolerant. Yes, but in computers are AI based techniques, so 100% no guarantee. And for learning, yes, we learn, humans learns, and for computers point of view, they learn a little bit, and based on the training and how we train it. And intelligent conscious, usually yes for brain, means humans, and usually for computers, it is not complete. It is not at completely planned or developed, still actually under development. So just like feelings, if you see, feelings can be done. No, it's like just expressing, like laughing or crying, or different feelings. So intelligent conscious, like how behaving consciously. So that needs actually, it's not that much easy. And machine learning and deep learning, actually these are all group of the AI, like part of the AI. So machine learning and deep learning are a branch of artificial intelligence where they need training, validation, and testing. And this DL is also a subset of machine learning that has network capable of learning unsupervised from data that is unstructured or unlabeled. Just like see, if you see, so you have the data, labeled data you are actually making a lot of training. So what we do is, with the features what they are trying, after training, they grasp some features and they store those features. If the input is given from they also take the features of the input and they compare to which particular image it is matching. So So here, so based on that particular input, we are able to make the output. So here, machine learning and deep learning, if you see, what other things we do. We use statistics also for inference from a sample, and we use a computer science like for efficient algorithms, or even for optimizing certain parameters, for representing and evaluating a model for inference. There are many things that we use in the computers, statistics, and many other things. And if you see the machine learning taxonomy, they look like this one. And so supervised learning, regression classification, and even unsupervised clustering. And whereas semi-supervised learning, so means partial. And for the dimensionality reduction from unsupervised, like single value decomposition, so like PCA, ICA, so principal component analysis. Like these are many methods we have. And in classification, classification is most used machine learning technique in most of the places, classification and clustering, either supervised or unsupervised. So these are the list of tools that are available in most of the uh, like highly used data mining or machine learning softwares, based softwares, just like Weka tool, or like there are many data mining based techniques and tools that are available as bundle of softwares. There are applications using this, like association, supervised learning, unsupervised learning, reinforcement. So learning association, just to know how the togetherness, like milk and bread, the study of buying together. So we use certain market basket analysis, and in data mining they use like there are certain algorithms to deal with, especially for learning association rule mining. There are FP growth, one of the important algorithms, frequent pattern mining. There are many other algorithms, right? So, and in classification, just to identify from the given data, you are trying to identify these are the data from these data is related to some patients, and that here these data is related to some patient, and we are able to tell these patients are at low risk, and these data is about some people, and we are telling that these people are at high risk. So this can be done with the classification. Not only that, if you see, so it's related to health, it's related to banking. If you see banking related, we need to identify the loan predicting, like pay, whether he is able to pay back the loan that he is taking. So for that there is a study. So they use they train certain models, and based on that they will try to identify whether these customers are at low risk or high risk. High risk people will never get that loan, and low risk people will get the loans. And as I have already shown some of the list of the classification methods, it is a bit more and further with details. Classification, like the application, if you see, like face recognition and character recognition, speech recognition, medical diagnosis, biometric, and even agriculture, civil engineering. There are many ways we use this classification techniques. And if you see the face recognition, we find the samples. The first row is related to the person with like labeled information for so and so person. All these are single, and then the test images are given. And when the test image, the first image, if they are got, and they should give for this label. All the images concerned to this label is, so we have to match to this particular. Assessing quality in agriculture food products, like we have um, some specific specially related to agriculture aspects, like knowing uh, the leaf diseases, knowing the leaf diseases by using the image processing or computer vision techniques. We extract the images, and then we study so the patterns. And after studying the pattern is good, then we can say it's the healthy. If the pattern is like doubtful, means actually they categorize. Initially they categorize. So these kind of data are one, this kind of data are another. So if they comes under the classification, the category of good, they will give the good, and if not, they will again give the hints to the there is probably there might be some problem with the crops. And there is for classification. So if you are using like certain marking the price of a used car with certain attributes. X is here, x-axis I have a mileage, and y-axis I have a price. So the best one where I can get as per my need, I need to, means actually the mileage you will be able to get. So the price, okay. So for if this is the case, price of a used car, like yes, I think this price y-axis, the price is getting increased, right? And the mileage, it should be reverse actually here. Oh, or more or less. Actually, these kind of studies can be done. Y equal to see, there is certain functions, certain models we use, and certain parameters we use to identify. Means actually so this is a simple example from some textbook I have taken, but actually usual process of purchasing a car, there is it's not a simple objective that we have. There are multiple objectives we expect, lot many, like I should have a good features, I should have a good less price, I should give features in terms of mileage, and the other features inside, like so whatever you say, all we have to combine, like objectives. Some are, means actually if you take all of them in terms of numbers, some objectives are in terms of minimal, some objectives in terms of maximal. So it's not a simple objective function. There can be a multiple objective function, multi-objective optimization used to purchase a cars. And there are certain regression analysis we use, and the predictive, since the time is very short, I'm just scrolling down. And predictive futures, like time series forecasting by knowing the current sensors. So in today's and the past histories, we'll be able to predict tomorrow's also. There are some predictive analysis by using a machine learning or AI based techniques. So and recommended systems. Uh, there are content-based filtering and collaborative filtering. Content-based filtering uses they use similar articles, means they study similar articles and try to recommend to the users. And when collaborative filtering, similar users read by both the users and recommend to the particular users. Means content-based read by user, similar articles will be identified, and that will be recommended to the user. Means actually I have only one and two users. Here collaborative, I have a two people, and in content based I have a one guy and who reads the article, and that articles we are trying to find out what are the similar article. So we use a recommender system, like where it uses certain concepts of AI based technique. Supervised learning uses like prediction future cases, like what we have seen in the previous examples. Knowledge extraction, compression, outlier detection. There are many uses. Now, unsupervised learning. So learning what normally happens, and just like a clustering, grouping similar instances. Earlier we don't have a label data, and we are predicting, or we are whatever we are trying to classify the data, group the data. They are actually based on certain assumptions, based on the distance measures, various distance measures, not only one simple distance that we are finding. We can try Manhattan distance, you can try Hamming distance. There are many distance measures that we can follow. for finalizing the clustering results. So there is another concept called reinforcement learning. So what they use is like they try to give the rewards as well, rewards and penalties in like they go for trial and error. In the trial and error, if the rules are good, then we will give the rewards to it. If the rules are bad, and we'll give the certain penalties to it. And finally, the what we try to achieve is through reinforcement learning, the score. We try to maintain the score. The score, whichever is having the high score, that will be given as a best one. And there are PSO, like in soft computing. Basically, if you see the soft computing, so we use evolutionary computing techniques such as genetic algorithm, genetic programming, and even um, genetic algorithm, genetic programming, and evolutionary programming, evolutionary strategies, and so those are the evolutionary based computing. Apart from that, we have a PSO, particle swarm optimization. That so PSO actually it is initially introduced by Kennedy Eberhard in 1995. What it main aim is, so it actually inspired by social behavior and movement of dynamics of insects, like just like birds. Birds are moving one side, like group of flocks are moving to the one side, others are moving the other side. Means huge group where it is moving, probably they are searching for the good. The
Sorry for disturbing you.
hello,
Hello. So there is some
hello,
audio issue since last 2 minutes. Sir. Can you
hello.
repeat the last slide? Hello? Am I audible, sir?
Yeah, please
Hello?
repeat. Yes.
So there is some issue regarding the audio from your end, sir. So can you
Which
repeat
one?
the last slide? Last slide. Uh,
This
Slide
one.
number 56. Sir,
56.
56.
Okay, fine.
Yeah, but this one.
Yeah. So actually I have 10-15 minutes more, so I should cover up. So I will
Yes, sir.
explain this one. Maybe I'll just wind up the other things. Okay,
Okay, sir.
fine.
Okay.
Okay, fine. So here, what was the reinforcement learning is reinforcement learning. It uses certain optimization techniques such as genetic algorithm is also part of the classification. Also, what it tries to do is it maintains rewards and penalties. In the reinforcement learning, ultimate aim is a kind of classification we try to do. And for making classification, we use certain rules. That rules, whatever the rules we are making, the new rules, whatever we make with the help of the genetic algorithm, that rules will be given either rewards or penalties that need to be calculated as a score, like something fitness, just like a fitness score or fitness value. So the one which is having the good fitness value, that will be considered. The one which is doesn't have a good fitness value, that will be rejected. And throughout this evolution, means actually instead of not only GA, you can apply any other combination as well. In the reinforcement learning, it's we deal with the rewards and penalties when the new rules are made. Right? Hello.
Yes, sir.
Okay, fine.
Continue, sir.
Yes, sir.
I have some slides to show. This is a PSO where for particle position, initial, let it be the present position, and then with what velocity it is going, and it has to also remember its best remembered individual particle position, best remembered swarm position. Swarm in the sense as a group, like I say, the best one where they are moving. So there are so I have like we have certain parameters as well, cognitive and social parameters. and random numbers between 0 and 1. We use all these things for making the next position and next velocities. We use the with what the new velocity with the for example new position to identify the new position of a particular particle. We use these formulas, equation 1 and 2, what we have, because with what velocity it is moving, right? And for the new position we have, just let me show you that actually. Yeah, so here I have so here what is the Vij? X is related to position, V is related to the velocity, right? And P, let it be Pti or Ptg, they are related to the part swarms related. One is I is individual, G is a group, and C1, C2 are a cognitive and social parameters, and that we try to keep this C1, C2, R1, R2 values with different values, but R1, R2 values should be taken in between 0 and 1 with different trial and error, with what value we are getting the best that we can apply. So I'm just going ahead. There are different evolutionary computation techniques in bioinformatics that. So in evolutionary computation or evolutionary algorithms, usual process is
Hello,
like
sir.
this. Hello.
Sir, in a PS4, you are saying that a new position is get added with the previous position and velocity.
New position. See here, xi t plus xij t plus 1 is equal to xij. It's a, what is the t plus
Yes,
1?
yes.
Yeah.
New position.
Yes, exactly. The present position plus
Yeah,
velocity
my
of the,
question is how the position is added with the velocity.
how the position. Okay.
Position is added with the velocity.
See, actually, you're taking the values in terms of. So here we are representing your algorithm in computers like some numbers, right? Hello,
Ah, sir.
you are using the numbers, right?
Okay, sir.
Hello,
Ah, sir, I'm listening.
yes. So based on the numbers, yeah. If I am okay, so let me see again. Uh, so you are talking about how the new position xi
Is
plus
getting
1.
with, yes, the
Yes.
position Xij is added with the velocity of updated velocity.
Okay, so here if you see this one, right?
Okay.
Hello, see,
Ah,
can you
sir,
see
sir.
this?
Yes,
Can you see this
I'm
image?
saying. I'm saying,
Yes,
sir.
yes, this is the position, and if you are adding that velocity, it will move to this, so over here the velocity.
Okay.
Can you see this diagram?
Yes, sir. I'm seeing.
Okay,
It
fine,
is visible.
you can take my number. If you have any query, then we can see. Okay,
Okay.
I'm just going ahead. So there are many like in evolutionary algorithms, what I said, what usually we do in evolutionary algorithm, if you see, at first we have to initialize the pair, like out of many population members, we have to fix the parents, that population size or parameter values such as PM value, like probability of mutation, or PC value if you use the probability of crossover, like that. We have to do certain initialization. Even it includes representation also, representation, probability of mutation, probability of crossover. There are many things that need to be initialized. The total population size that need to be initialized in the beginning in all almost all evolutionary algorithm. Then after that, whatever the population size you fixed, let it be 4 or 5 you fixed in the initialization, that 5 size will be used for the throughout your evaluation. Let it be, if you fix it 100 as a population members, so that population members 100 will be there in every iteration. Every iteration 100 will be used as a population size. So here, what we do after the initialization, based on the population size, the parent selection we have to use. In the parent selection, what we try to do is we try to do certain kind of like statistical measures to know who are good, who are bad. If you know some are good, one is a bad. For example, out of four, for example, if you fix total is a 5, out of 5, one is a bad, and the 4 are good. Out of 4 also, with the help of the statistical measures, we will try to identify who is the best among them. The one who is the best among them, that actually replaces the worst one. So after replacing that, the parents are selected, and the crossover can take place among them. Like after selecting the parents from the population, the crossover or mutation can be done. Crossover should happen in between two members, two solutions, or whereas the mutation that can happen only among the one solution. In the one solution, we just change the one of the bit value with the help of the mutation techniques. Actually, if you see, there are many examples. It all depends on the type of representation what you take. For example, if you take binary representation, there are just I'll show if I can. I'm not sure. Let me see. Yeah, usually in the initialization, the population size and the solutions are there, and the selection, this is the selection. Parents are selected and they go for crossover because it happens between two. So to make the new children means some property from the first parent, some property from the second parent, and we get the children. Means so we'll get the new solution. And similarly, so another selection, from the another selection, we got the new solution. Some property from the first parent and second parent, you get the. And similarly in the mutation, if you see from the one individual only, we change the some of the parameter value or the these features. So after changing the features, you will get, the earlier was the size was less and the size was big, and the color was also become thick. Like that means actually we, out of the many features, we are trying to modify some of the features with the help of the mutation technique. How the mutation can happen, it all depends on the PM value. Actually, how they treat is all the solutions kept in a binary representation kind of thing. All the solutions are kept continuous, and for every bit, we are trying to generate a random value for every bit, and we have a PM value that we set, let it be 0.04, or based on our study, we fix that PM value as some value. The random value which was generated for every bit, we compare with the PM value, the generated value for every bit which is less than PM value, to that value we will flip the values. I am talking about the binary representation. In the binary representation, that works in this way. So likewise, we go for the mutation, and for the crossover, what we do is just some of the identifying the location where we are taking some half of the some portion we take from the first parent, half of the second portion from the second parent will take to get the new children. Like that, you will have different combination of results in the in this evolutionary approaches. Usually, historically, our usual understanding is binary strings are used for genetic algorithm, real valued vectors are used for evolutionary strategy, and binary state machines are used for evolutionary programming. List trees are used for the genetic programming. But this is not the case. That means we also can change also. We also can change in the sense, nowadays many people are trying different combinations. Even like binary, instead of in genetic algorithm, instead of binary string, they can try for the real value vectors or the numeric values as well. So they can go ahead with the different combination nowadays. It's not strict now. Means the research, I am talking about the research. If you are able to make in that way, it's okay. As per the conceptual thinking that had with that particular technique. If you are able to do, then only you are, means that should fit to that particular concept. If it is not fit, you can't make it. Research areas in bioinformatics, these are the different research areas in bioinformatics: alignment and comparison of DNA and protein sequences, and gene mapping on chromosomes. These are various research areas or the research topics usually that we use in bioinformatics. In these bioinformatics applications also, we apply AI or ML based techniques. So it's almost 12:20. So I'm sorry, I have some other appointment, I have some other thing. So these are the just for understanding, this is a list of areas where bioinformatics, research areas of bioinformatics, and in these areas also we can apply the AI based techniques as well. Okay, so maybe due to time schedule, as I have already told to Professor Raju Bhukia sir, regarding I can give only 1 hour since I am busy with other schedules. I have a meeting with other faculty colleagues. So I'm sorry for leaving. Maybe I don't know what time it was kept. When he was asked me, I told him I can take 1 hour since I am very busy now. So thanks for all of you for to carefully listening to me, right? And
Yes, sir. Yes. So, this bioinformatics is the new kind of the concept for many of us, and we are very thankful to give your area of the work in the bioinformatics and how the AI and the machine learning and what are the other algorithms can be useful for the various kind
yeah,
of the
actually,
applications
the
of the
one thing I can tell, I can answer 1 or 2 queries, the important queries. What are you're asking is in bioinformatics, how we can use AI or ML based techniques, right?
Yes,
Yeah, fine. So basically, if you see the in bioinformatics, one of the earlier we used to do microarray data analysis. In the microarray data analysis, we try to apply various evolutionary algorithms or nature-inspired algorithms, or so even almost all classification clustering techniques for different different study to know to give the accurate results for classifying. Classifying means correct classification. In the microarray data, what we have is like you have one either in the row sides or the column side. One side we have the samples, other side we have the genes, and these data is not just very simple. It's actually having a huge data sets, and there some rows or some columns are not that much useful. So we need to means actually it's a high dimensional data. To deal with the high dimensional data, we have to apply certain evolutionary approaches or nature inspired algorithms to increase the accuracy of this classification. And the classification ultimately the classification gives whether the particular from the data given microarray data, for example, if the data set is microarray data set is cancer microarray data, the cancerous patients or non-cancerous patients is the ultimate goal. So out of the given huge data sets, we will be able to predict whether he is the correct accuracy, how good it is performing by applying the different AI based techniques. Especially GA is used more, PSO they have used, and multi-objective PSO they have used, multi-objective genetic algorithm they have used, or NH, like in multi-objective genetic algorithm also they have used NHGA2. Many people they have used. There are many papers in IEEE transaction or in bioinformatics specialized journals. There they are trying to means the what research they have done, what they use the evolutionary algorithms, optimization techniques for optimization of different parameters to increase the accuracy. So that was the main idea. So if you see the microarray data related study, you will get a lot of understanding. Nowadays the NGS data, and drug discovery related or active sites related some research is going on. And even in drug discovery, especially when it comes to the corona related, the pharmaceutical industry, they are trying to use most of the bioinformatics tools nowadays. right? Okay.
Okay, sir.
So
Okay.
right.
So thank you, sir. On the behalf of the GTU British School of Engineering and Technology.
So I'm sorry, I have so crossed my time. Some people are waiting. Actually, there is a meeting for certain results declaration. So I am also member
Okay,
for
okay, sir.
making presentation. So I
Okay,
should
sir.
go. So
Yes,
thanks
sir.
for your time.
Thank you very much, sir. Thank you very much for
Thank you.
your sparing your valuable time and sharing your knowledge and research in front of
Thank you. Yeah, thank you.
participants.
Sometime if time permits, we may meet in some other meetings lively. We can enjoy.
Okay, sir. Okay, sir.
Right? Thank you.
Yes, sir. Yes.
Thank
Thank
you.
you very much.
Thank
Thank
you
you.
all.